Welcome to the session, and this is basically the first session in the series of four-part that we have, right? And it's divided into the four sessions, and these sessions would be done differently than you might have seen any other Azure fundamental training over the YouTube. For the reason, because I'm going to focus mostly on the whiteboard, and the content that we're going to cover in this session would be, I hope you can see my screen. There are 6 items that we are going to talk about in this. And since we're talking about cloud computing, right, more into the Azure context, I think before we even delve into cloud computing, we will start with a case study where we would try and understand, how, let's say, a typical business or a small business basically starts its journey. At what point in time do they basically feel a need, right, to get rid of the manual stuff that they have been doing to operate their business, and they decide to adopt technology. They decide to adopt software or, let's say, hardware, right, to drive their business growth. And then from there, at what point does that business feel a need really to adopt technology such as cloud computing, right? So before we appreciate what cloud computing can do, we will first try and understand what are the challenges that a hypothetical business entity that we are going to talk about faces as they delve into their business and they witness, let's say, significant growth. How does the cloud addresses all those challenges that emerge out of that, right? So that's basically the first thing that we're going to talk about here. Okay. Second would be, once we have understood the problem, right, then we will relate it to what cloud computing is and what benefits does it bring, and how those benefits are addressing some of the challenges that we have understood from case study 1. Okay, so we will talk about that right here. So why cloud computing, right? What would happen if there was no cloud computing for the same business that you're going to talk about? Okay, so we will talk about all of that. Now, as in any area, it is good to get familiar with, with the terms and terminologies, right? So there are some key terms and terminologies that you need to get used to when we talk about cloud fundamental or basically computing in cloud in general, right? So we will cover those key terms here in point number 3, right? And then we will talk about, although you might have heard about public cloud, private cloud, and hybrid cloud, but just stay with me, right? Stay here to hear my perspective on that and what does it mean, because there are many people, who actually get confused about, hey, how do we differentiate between, let's say, private and hybrid cloud, right? How is private cloud different from my own data center, for example, right? So we will talk about all that. So we'd like to draw absolute clarity there, right? And what are the benefits, advantages, and disadvantages of each, right? Or basically the strength and the weaknesses of each is what we are going to talk about here in item number 4. And then we want to double click on something that is very important to understand, because in cloud there are 3 ways in which services are offered, and those services are basically categorized into 3 areas. A service in cloud could be IaaS, right, which is infrastructure as a service, or it could be platform as a service, or software as a service. So we'll take a practical example. We will start from very basic, and then we will basically peel it one by one as to you understand clearly what these 3 things mean. And we want to start with a very simple and very basic type of example so that you can relate, right? You can understand, it can retain. And then in number 6, we're going to talk about core Azure architectural component. Now, as we talk about the benefits of cloud, as we talk about the benefits of cloud here, some of the benefits as they come up, right? They are basically coming up from the architectural components of Azure, how Azure is architected, right? So that is basically giving those strengths, those advantages to the cloud, right? So it is important for us to understand those architectural components which are powering or which are providing those benefits. So with that, let's get started with the case study first. And we're going to talk about, an entity which is called Bella's Boutique. So who is Bella? Bella is basically somebody, right, who has been basically very, very creative since her childhood. and she learned, how to make basically handmade jewelry from her mother. And as she grew up, right, she was always into opening her own business. And as she graduated from the college, she actually decided to open up her own business in the town where she was living, right? So she was basically living in one of the town in India, right, in the state of, let's say Karnataka, right? So it's basically a state in the southern part of India. In a small town, she started that business, and the way she started that business was that, she basically got a small shop to begin with, and she started, basically creating those handcrafted jewelries, and with all the display and those sort of things available in her shop, and people would just walk over the counter. They will choose whatever they like, they would pay, and what Bella would do is that, she would give them, collect the money, right, keep it there, record it, maintain the ledger, do the invoicing manually, right? Everything was manual. And then what happened is, as more and more as more and more customers, right, started coming in, as her shop got really, really popular, she actually hired, a couple of more people as well, just to help her out. And these would become her staff. And now they were actually creating more and more handmade jewelries, and all the entire staff was basically helping her to run this shop right here, right? The number of staff actually grew. And what happened is that, as a result of that, the amount of manual or laborious work that she had to do actually increased significantly, right? She saw that customers were basically liking the product. They were coming and they were purchasing from within the town, at least, right? If not from so far away. But behind the scenes, she was having to do a lot of laborious work, like maintaining the invoices, maintaining the cash, right? Keeping track of the inventory, etc. And it was all paperwork. And pretty soon, she realized that there has to be a better way, right? So then, what she did is that, she actually got in touch with one of her friend who used to work in IT services company. And what they decided to do was that, how this friend of her could actually help her digitize the estate, right? So whatever she was doing right now, how can all this be converted and take her business to the next level, where she doesn't really have to worry about, any of these manual tasks as she was maintaining, right? So with the help of the technology, how she could push her business right from phase one into phase two, where she can actually then accelerate further sales, right, and further customer growth as well. Now, what this friend of her helped her do is to basically set up her own small IT estate, right? So what she did is that, beside her shop, she basically rented another shop there, and she actually converted this thing into what was called as basically a server room, right? She got all the racks and all the storages purchased, right? All the networking equipments, etc. She actually deployed in that room with the help of that friend. And they basically help her do two things. They basically help her develop, with the help of this software and hardware, they help her develop a website on which she could then take pictures of this product and she could then upload, right? And then she wanted to open up so that there is a website, everybody can purchase that, and then she would work with the delivery providers, right, who would then ship that product to the customer. So that actually was going to bring a lot of boost to her customer. So they were the website to maintain. But on the other side, in terms of the data as well, if you see, there was a lot of data, such as, invoices were to be maintained, inventory was to be maintained, right? All the transactions that were happening online or even in store, right? Because she was basically adopting technology more. All that actually created a lot of data, as you can imagine. It actually created a lot of data. In terms of the data, data was basically, number-based data. There was text data, and as well as there were images, as you can imagine, of the product. Everything had to be stored. So in this particular shop, what she did is that she basically got some some compute capacity, right? Some compute capacity. Compute capacity means there were server racks, right? Bare metal devices, which were kept over there. So these were basically the servers and the racks. And then beside that, there was basically storage layer. So there was a lot of storage that was provided to her. And then what happened is that the storage would get used to store all this data, images, text, and numbers. All that would go to the storage. On top of it, then there were racks on which there were servers deployed, and those servers would then host the website that we had, right? So this website would be hosted on the servers, and as long as servers are up, the website is up, right? The website is accessible to the customer. Now, she actually provisioned the power backup as well, because she realized pretty soon that that my business is based out of a small town. And what happens if someday there is a blackout, right? There is power disruption. She actually provisioned the power supply as well. So basically, things like things like inverter or the power backup were provisioned as well. Okay, so everything was going fine, and her business actually moved from phase one to the phase two. And then what happened one fine day was that there was basically a complete blackout, in the entire area. And unfortunately, her power backup that she was leveraging upon, that was completely consumed, and thereby there was no power supply available, and therefore her website went down. And due to that, on a daily basis, she actually saw tens of thousands of sales loss because website was down. The orders could not be placed. Although over the counter sale was still continuing, but online sale stopped completely, right? So the first challenge that she realized was here, that in case something goes wrong with this particular setup, my business would be put to standstill, right? Okay. Things were things were restored, right? So what happened is that the power was restored, and then what happened is, so this is scenario number one. Scenario number two, during festival, during festival, she would witness tremendous amount of increased transactions, right? Increased orders. And what she realized is that basically, 40 thousands of USDs that she had spent on provisioning this server and everything else that she spent is not able to cater to the demand as it is coming in, right? So if we talk about, let's say, the festival in India, and if we talk about Deepavali, for example, then what happens is there is this period of, let's say, 1 week where there would be more and more sales happening. Thereafter, when this is gone, then we don't perhaps require that much of hardware or that much of compute power to be powering her website, right? So then she actually understood another challenge with this setup, and that challenge was that it is not elastic. The setup is not elastic at all. If I have to cater to the demand of the festivities, I might have to perhaps purchase, let's say, another 40,000 USD worth of hardware, and just to keep it in my room, and I'm only using it for a week. It is not workable, right? So that elasticity challenges came up, right? Basically, disaster recovery type of challenges basically came up as well. Okay. And then, as you can imagine, with this setup, there are many other challenges also. If due to any reason the shop actually goes down or the server room goes down, then everything would be down. There is no high availability, right? Now it was getting increasingly expensive for her to basically provision a DR site in that case, and then have a mechanism to copy over the data from this particular room to the another room. And for that, she had to spend more and more money, right? So a lot of challenges. She decided that this will not scale, right? And then she basically got in touch with the same friend, because she actually wanted to now get over all these limitations, all these challenges that she was facing. And that actually led to the phase three, in terms of the growth of a business, where she actually got in touch with the same friend. And by that time, some time had passed, and the cloud technology was becoming very, very popular. And they started having a conversation around the cloud technologies. And her friend basically explains to her that how implementing computing in cloud is different than doing it in on-premises, right? Firstly, she basically, wonders as to what is this cloud computing thing. Can you explain to me in simple language? Tell me what this cloud computing is. And her friend responds saying that now having seen how a business is run in on premises in your shop, you needed essentially three things to power that business using technology. And those three things were: number one, compute. You needed compute. Compute would be, your CPU power, for example, right? So you need some compute, which was provided that you bought the physical hardware. In addition to that, compute would also require, basically memory, the RAM as we have in our laptops in general. In addition to that, she required a lot of storage because there was a lot of data that was being generated as well, right? Uh, so in terms of the storage, yeah, storage would be required as well. And there is second thing. Other than that, networking equipments, right? That would then let her on-premises shop connect to the internet, make the website that is hosted here available to everybody over the globe, or at least at least in her town and beyond within India, or perhaps globally if she's really ambitious. So all that was required at the first place. Okay. Now her friend tells her that imagine that all these services are actually provided to you by somebody. And rather than you owning or purchasing or acquiring all of that and finding a place to fit in somewhere in a physical location, we let a cloud provider to manage that for you, right? And you can use these services in on demand basis is what cloud computing is all about. So cloud computing, he's telling her that is all about providing the compute resources, storage, networking, monitoring, backup, recovery, all that, all those capabilities to you on on-demand basis, and you no more have to own all these infrastructural component, but you just go there and you rent it out, and you rent it out for as long as you want that. Whenever you don't want, just release it and you don't pay, right? And this actually sounded very attractive to her. Okay. And then her question was, hey, all right, we're talking about cloud. I think sounds like a good idea, but where do we go, right? Who do we get the services from? So of course, in terms of the cloud provider, when it comes to the when it comes to adopting the cloud, then the next question was, all right, tell me key cloud providers. So of course, we have Microsoft, right? Now her friend basically happens to be advocate of Microsoft technologies, and she basically decided to go ahead with Microsoft. Now her decision was made. She understood what cloud computing is, and thereafter she then wanted to go deeper into, now first tell me, how would the cloud computing address some of the challenges that I was facing in my on-premises environment? Okay. Now we start with the challenges. So we understood cloud computing with that. Now let's talk about some of the key concepts that actually come in, or some of the benefits of cloud computing. Okay. So we'll talk about benefits of cloud computing now. Benefits of cloud. And apologies, my handwriting is not so good, but I think as long as you can understand, it should be fine. Firstly, she was basically concerned about how high availability challenges would be dealt with. Yeah, basically high availability challenges. And she was told clearly that high availability is one benefit of cloud. Now she wants to understand as to how high availability is dealt with when she decides to bring this website over to the cloud. Okay. Now, rather than talking just the simple day-to-day language, in order to understand the benefits of the cloud, let's get to the specific technical concepts to understand how does cloud, something like Azure, provides you high availability. Okay, so we are now transitioning from the pure theoretical explanation to understand how high availability is delivered, and consider that this friend of Bella is answering that question of her, right? So that she can better understand high availability. How does Azure work? Azure is basically a global, cloud service provider from Microsoft, right? How it works is that, see, at the end of the day, at the bottom, for example, if I'm based out of Singapore and Azure is providing services in Singapore, they have their data centers here in Singapore. They have their physical data centers, right? But you don't really have to take care of that. So they are managing it, right? So at the bottom, we would still see data centers, but as long as you are not managing it, it's fine. Okay. So high availability basically means that she basically decided, to deploy her website at one location, right, in one of the data center in wherever she was staying in Karnataka on Azure. What Azure would do is that it would automatically, uh, you know, it would automatically replicate, right, this thing over here. And when it comes to the end user, the website would be, because website would have it deployed, right, over more than one instances in Azure data center. The user would be basically would be connecting to a common point, which is basically kind of a load balancer, right? And behind the load balancer, Azure would automatically take care as to whichever server is up would complete the request, would send the request to order that handmade jewelry to the backend server. And this will be taken care of by Azure automatically. So high availability would be there because it would be replicating whatever you are putting in there, which is website in this case, to another server in another data center. Not just in another data center, but it could be that another data center in another region itself. It can do that, right? So that's how it would provide high availability. Then she actually, talks about, uh, hey, tell me about scalability. Scalability during festivities, I have basically a lot of demand, right? How would this address? If I were to move my websites from these physical servers to Azure, how would this address that? And her friend basically tells her that, hey, see, today you are provisioning a VM which is this big, let's say, in terms of CPU and memory, it is this big. But during that festivities, Azure will provide you scalability, by which you can basically, you can scale up. You can scale up this server just for the week in which you are expecting more orders to be coming in, only for that week. So it will scale that up for that 1 week. Once that week is gone, it will scale it down. And you are again paying for only what you're using. Only for that 1 week period, you are paying the additional cost, but thereafter it would automatically bring the size down for you because you're not expecting anymore, those many requests anymore, right? So you would pay only for what you are using. It will provide you scalability in that sense. So high availability and scalability, and of course we will go deeper, okay? But yeah, but see that now. Uh, Scalability, could be all right. I think let's park it here for now. The other thing would be basically disaster recovery, right? Because she was she was witnessing that there was a power cut and the uh, and the premise actually went down, right? And then the power had to be restored for her to bring her website up, correct? There could have been other scenario where, let's say, something goes wrong, right? There is, let's say, there is some physical damage, right, to the shop, right inside the shop, and that actually leads to for example, damaging the data, right, or damage to the actual hardware as well. In that case, how do you restore that? So her friend actually tells her that what you can do is that, let's say if you are staying, out of one state in India, let's say state one, Azure provides this automatic capability that your website and the associated data, all the data, your product data, invoicing, transactions, etc., it can actually make a copy of all of that and it can put it in another location, right? Perhaps in another state. If this is, let's say Karnataka, you can actually send a copy of this to Delhi. So Karnataka being in the South Delhi, Delhi being in the North Delhi, you can actually do that. And it is highly unlikely that even if there were to be a natural disaster, right, one location might go down, but not both. And this is inbuilt. You get it for free. So you don't have to spend so much of money as you were anticipating earlier, right? So this becomes the third benefit of cloud computing, that it gives you disaster recovery built in. Okay, right. And now, uh, there are many other things. For example, yeah, and one thing I would like to touch upon is the global reach. Global reach. Now, if Bella is really ambitious, then what she would want to do is that once she has launched her business, she has migrated over to the cloud, her website is running in the cloud infrastructure, she would want the product to be sold out not just in India, but outside of India as well. And therefore, she realizes that adopting something like Azure would actually open up a lot of opportunities where she can make her website hosted across many different regions, right? Not just India, not just Asia, but America, Europe, Middle East, everywhere. And as long as she can take care of the logistical part, which is to ship the product, this would actually significantly boost her business as well, right? So that global reach she's told that she's provided with, right? So for example, let's say we are talking about India region right here. Yeah, so we are talking about India region. She can actually host the same website in US region, the same website in Europe region, and all that can be done very, very easily. Now she doesn't have to maintain those physical shops basically there, right? She can just, with the click of a button, she can replicate all this, and this website can be available across all these regions, and orders can be placed. Okay, so this global reach is available now. Although she's based out of the small town, but cloud technology has actually opened up a lot more opportunities for her. Now, the other thing is agility. Agility. We talk about agile. Now, initially, when she set up her small on-premises data center and she bought everything, it actually took us it actually took her about 2 to 3 months from the point she got in touch with her friend to then acquiring the hardware, installing the software on that, right? Developing the website, testing the website, deploying the website, and having it operational. It took almost 3 months because it included the time that she required to provision the hardware and install the software, etc. There was no agility. It wasn't fast enough. So now with cloud, if let's say tomorrow she would like to expand her business to not just sell handmade jewelry, perhaps also sell, handmade clothes, for example, she can very quickly spin up another website very quickly on the same infrastructure and make it global very easily. She doesn't have to worry about provisioning all that infrastructural component. So now she's able to bring her product, her ideas to the market really quickly, and that is what exactly the agility means, and that's what cloud provides you. These were some of the benefits that actually came up, and Bella was convinced that there is no reason we should not go to the cloud, right? Because what it is doing is that it is basically providing you high availability, scalability, disaster recovery, global reach, and then agility also. And then also she doesn't have to spend so much of money as well, right? Because only when she requires a little bit more compute or storage, she will take it, right? She will take it. And as soon as it is not required, she can release the resources. So that actually would help her save cost as well, correct? because she's only paying for what she's using, right? So from the cost perspective, from the cost perspective, it actually becomes a lot more efficient. It becomes a lot more efficient, right? It becomes basically faster when it comes to agility, and when it comes to cost, it becomes a lot more efficient for her to run that business, right? So these are some of the benefits of the cloud, and she understood all of that, and with that, she basically got a little more curious as to, since you're talking about that it would cost you less, how would it cost me less? Can you explain that to me? So that's where this concept of economies of scale basically comes up. Economies of scale. So let's talk about this thing called as economy of scale. And you will basically hear that a lot. Economy of scale basically means, or it basically is the ability, right, where, okay, so it's the ability of the cloud provider where they invest so much of money in provisioning so much of compute power at scale, right, that maintaining some of the overheads, for example, in terms of the power supply, right, in terms of the maintenance, in terms of the operational cost, and in terms of the security aspect, it actually becomes a lot more cheaper for them because they are doing it at scale. They are doing it at scale. For an example, if Bella had to take care of high availability, disaster recovery, security, networking aspects, agility, all by herself, it would have become very, very costly for her. But since Azure is building that infrastructure from bottom up in such a way that they have regions, they have data centers all across, they are built in to support high availability and scalability and fault tolerance, etc. It actually becomes a lot more easier for these cloud providers to support all these capabilities by spending less money, right? Because they are basically doing it at scale, and they know the optimal way of doing that. That a business alone can't actually possibly do that, right? So this economies of scale, that you do it at scale, you can actually then do the same thing that would otherwise cost you so much more cheap, in a more cheaply manner, right? And as a result of that, since it is cheaper for Microsoft, for Azure, they can actually offer these services back to you at the cheaper cost. So that is what economy of scale is basically all about. Now, just to absolutely make it clear, cybersecurity, right, is a very popular area. There are security threats, cyber threats everywhere around us. Imagine Bella having to take care of security by herself in her own premises. It is not possible because threats are emerging every single day, and there has to be defense that should develop much more aggressively than the threats. There is continuous investment which is required. Bella in her own data center would never be able to match that. So therefore, we let something like Azure take care of that. They do it at scale. They can keep up with the pace, but they provide you the same capability, same security at a much cheaper rate. So that is economy of scale. I hope you understood that concept now. The other thing that I want to talk about, because we were talking about some of the key terms and terminologies when it comes to cloud. There is this term about, and I'm sure many of you must have heard that, capital expenditure, right? Capital expenditure to operational expenditure. So so what it means is that in short, we sometimes say that we are moving basically from capex to opex. Yeah, so please understand this concept as well. What it means is that when Bella started the business, she had to provision everything, right? She had to look out for a place, rent out a place beside her shop. She had to purchase all this hardware, software, networking equipment, and get somebody to assemble that, right? and then she had to pay the cost upfront, right? Making an estimation as to I might expect 10,000 customers, right? 10,000 customers at any point in time. And keeping that in mind, keeping that scale in mind, she had provisioned the hardware, or she would provision the hardware. But she has to pay for everything upfront. 100% cost is paid upfront. Now, that would also make her to buy a little extra capacity just in case required, right? Because more is better, less is not better, correct? But she will have to pay everything upfront. And that becomes capital expenditure from a business perspective, that you have to pay everything upfront. The benefits that you're getting from it in return would actually come up eventually, but you have to spend everything upfront to provision all those hardware, software, and everything. That is capital expenditure, right? You might use it fully or you might not use it fully, but you must spend money to provision everything now. Okay, that is capital expenditure. As you move from on premises to cloud, it actually becomes operational expenditure model, which actually means that now, it is similar to how you pay your utility bill, your electricity bill. As much as you pay, or as much as you use, you pay, right? You use more, you pay more. You use less, you pay less, right? So just understand that as we move from on premises to cloud, as we adopt cloud, we are transitioning from capital expenditure to operational expenditure model. Okay, so that is what it means. You are not billed immediately, but you only pay for what you're using, and that's why you would actually hear this term, which is very commonly heard in cloud computing, right? Which goes like pay as you go. So you pay as you go. You don't have to pay anything upfront. The more you use, the more you pay. The less you use, the less you pay. Okay. So there is no upfront cost when it comes here, and you only pay for what you consume. So perhaps Bella in this case, during festivities when there is a lot more demand, for example, she would pay a little more to the cloud provider like Azure, because more and more customers are coming up, and more compute power is being provided to her, right? Let's say the size of the machine is actually increasing. uh, Azure is allocating more compute, more memory to the server, to the same server for that period of 1 week. So she's actually paying more within that 1 week. But once that is gone, then again, the size is restored back to the original, right? So she's only paying as she's using, as she goes. Okay, right. Now, just to very quickly circle back, what we talked about, she basically came to the cloud and we talked about some of the benefits of the cloud: high availability, scalability, disaster recovery, global reach, agility, and cost effectiveness, or basically pay as you go model, right? We talked about economies of scale, which means that the more you do it at scale, the cheaper you can offer the services at. And then capital expenditure and operational expenditure. In on-prem, it is always CapEx, and in cloud, it is OpEx. Okay. So then now we will talk about various types of clouds, right? Various types of clouds. And we were, mainly talking about three types, where we had, private cloud, we had public cloud, and then we had hybrid cloud. What does it mean? So you understand it in this manner, that Bella was running her infrastructure in her shop, right? She was responsible for everything, if you look at it, right? It was the entire setup was owned by Bella. In case anything goes wrong, let's say the rack actually is broken up, some hardware is spoiled, there is power which is to be provided, it is all the responsibility of Bella. She has to take care of that, right? Because she is in full ownership of that of the data center, I would say. Okay, and that is equivalent of private cloud. Now, Bella's is running a business, so it is actually an entity, right? It is a business, and that business is hosting all the solutions, all the applications that it requires to run its business in their own data center is actually called private cloud. Okay, you have to manage everything. Though you manage everything, but you get full control over that. So please understand that, right? You have absolute responsibility to manage everything, but you also have full control, right? So in a way, it actually increases overhead, your responsibility, correct? Uh, but on the other hand, it actually gives you absolute control as to you can do whatever you want with that. Okay, so we will actually take a look at what does that control mean and how increasing that control or reducing that control would make an impact. We will get to that. But this private cloud is basically when Bella was running it in her shop. This is private cloud. Okay, private and then public cloud. Public cloud is when she actually decided to go over from on premises to Azure. Okay, on premises to Azure. She came on Azure. Azure is basically a public cloud provider, right? It's a public cloud provider. Now, when it comes to public cloud providers, there are benefits. For example, now she doesn't have to maintain, that infrastructure. It is all maintained by Microsoft, right? And she was in the sole ownership of this entire data center, right? She was in full control, absolute control. It is not that there is another shop beside her and that shop is actually also sharing the same infrastructure to run their website. No, it was in complete ownership, right? Public cloud is slightly different in that aspect, and we call this thing as single tenanted, right? Tenant, basically renting. Who is renting? If there is only one entity renting in the private cloud, it is Bella's boutique. It is single tenanted. Public clouds are multi-tenanted because within the same region, within the same data center, you might have Bella's boutique, you might have Simon's boutique, right? You might have Ajay's boutique. They all are requesting for the compute, requesting for the space in this entire Azure, and then they are all basically running their businesses over there. So for that reason, this is actually called as multi-tenanted. So public cloud is multi-tenanted. You don't have absolute control. You can't say that, hey, show me how are you running your servers. Show me how are you connecting them together. You don't have to worry about that. It's not your responsibility. So you have less headache, right? Less headache, but of course you lose control, right? Because you're not in control of these low-level things. In fact, you don't have to be. You don't have to be in control of all these things. So that is public cloud, such as Azure. Hybrid cloud is basically when you imagine a bank. Imagine a bank, right? Bank is dealing with a lot of private data, customer sensitive data. Or imagine somebody like a government entity, right? Like Ministry of Defense or Ministry of Home Affairs, etc. As much as they want to adopt public cloud and shut down their data centers, there would always be uh, some data sensitivity issues or data residency issues, right? Or basically some governance requirement that would mandate these security related agencies in our respective countries to keep the data, because it is highly sensitive data, within their own control in their own data center. On one hand, there might be other applications where the classification of the data is not so sensitive, right? It's not so sensitive. If it is not so sensitive, they are okay to move that to cloud, to Azure. But what does hybrid mean is that for a bank, if they have some sensitive data that they still want to keep due to the compliance reasons, due to the regulatory requirements, they can keep it in on-prem. So hybrid basically means that you put something, you keep a few things on private cloud, and you move other things on the public cloud. So it's basically a combination of both. Now you can choose, all right, application number one, application number two, I would like to continue to run here in my private cloud, which would be basically similar to how Bella was running her business, right? On the other side, all other applications which are not holding, let's say, so much of personal data or sensitive data or whatever, those applications can move to the cloud. So that actually gets moved to something like Azure. But then when you do that, of course, there is a requirement that these two should be able to talk to each other. But we will talk about that later when we go to the services. Okay. Now that is hybrid cloud. Private, public, hybrid. Understand one more thing when it comes to private cloud. One more thing. We talked about Bella's example, right? Bella Shop is an example of private cloud. On the other hand, what might happen is that Bella might say that, hey, I don't want to manage these data centers myself. Although I'm sure that I want to keep it, within my town itself, but I don't want to manage this myself, right? She can actually, she can actually, uh, give this responsibility to a third party as well, to a third party provider as well, which are basically maintaining the data center on their behalf, on her behalf. And that could be another example. Now, let's say I basically give this responsibility to, to a IT services provider, to a IT services provider, and that provider is now responsible to manage this data center where Bella's website is running. Okay, so Bella is not maintaining that herself, but she has actually given this responsibility to a third party that is managing that data center for her. But it is still privately held, right? It is still private cloud. Okay, so keep that keep that in mind. So with that, I hope that brings some clarity over what public, private, and hybrid cloud means. Now you think of it in this manner. If if Bella's website was hosted in the private cloud, right? And her data, her invoices, her images, product images, everything was stored here in the private cloud. And she needed to access that. Now she is here. She needed to access that, right? She can get it locally, correct? Because everything is in the room. Everything is in the room. She can very quickly basically access it and make use of that. But when it comes to the public cloud, how do we access? We access it over internet because these services are available on demand to you. But in order to use those services, in order to connect to those services, you need internet, right? So that internet connectivity has to be there. As long as it is there, you can go there, you can connect to the resources, you can connect to the website, you can get your data or whatever. You can do that. Okay. So keep that in mind as well. Hybrid model basically gives you flexibility also. Keep that in mind also. For customers like banks, right, or the government organizations, for example. So for them, it is very much required, or it is a mandate that they want flexibility to choose what runs on premises and what runs in the public cloud. So hybrid actually gives them a lot of that flexibility. Okay. If I were to ask you which would be the most easiest from the maintenance perspective, it would be public cloud because Azure is doing that for you. They are maintaining it for you. If I were to ask you from the control perspective, which one has more control? Definitely, private cloud has more control, gives you absolute control over how you want to run. In case of Azure, you can't actually argue with Microsoft, hey, tell me how are you running your data centers, right? And I want to intervene. No, you can't do that. Okay. So these are three types of cloud providers. Okay, now we will talk about another thing where we will get into talking about infrastructure as service, platform as a service, and software as a service. Okay. Now, what are these three terms, and what is the best way that you should be looking to understand them? Let's take an example. Okay, we start from the very basic. In this case, we go back to Bella's shop, right? What she did is that she basically provisioned these racks in her shop, right? This piece of hardware. So these were basically these big racks. There were storage available as well to store the data, and they were basically the networking devices to connect everything. And then out of that, there were there were basically machines created, right, using virtualization. Don't have to worry about what virtualization is, but these are not physical servers. If she needed 10 servers, not that she would require 10 CPU as we buy normally, right, in for our house. No, it is not needed. You can actually have a one big server, and then you can do virtualization on top of that by using Hyper-V or VMware type of softwares. And then you can actually take a take some amount of that compute and you can create its own virtual machine. What is virtual machine? Same like your laptop, as you're running your laptop, right? My laptop has an operating system, Windows or Linux, right? That laptop also has some compute like CPU. It has memory. It has some storage attached to that, right? It has all of that. So when I say machine or a virtual machine, it is similar to how your laptop works. Okay, one individual machine is that. Now, the VMs, these virtual machines, are are then crafted out of that big rack that we have in Bella's shop, is how it is done. Now, infrastructure as a service. Now, since she has decided to move everything to the cloud, what happens here is that for her, there are three ways in which she can think about moving all whatever she was running in on premises to cloud. And what was she running? She was running a website, right? So she was basically running a website. Now, what she can do is when we talk about infrastructure as a service to begin with, right? Infrastructure as a service. What happens is that Azure would tell Bella that, all right, this virtual machine that you are running, this virtual machine, right? Let me just expand that here. This machine that you are running, one machine, this machine can be moved over to the cloud as is. You can move it as is. Okay. So it is still like a machine on the cloud, right? And if you open up this machine, what happens is basically what are the building blocks of this machine? If you were to ask me, see, the building blocks of these machines are they basically require storage. Okay. Or maybe to make it easy, let's do it this way. So I don't really have to write so much. I'm going to just take basically, uh, yeah, basically snapshot of this image and I'll put it here. Okay, so yeah, this is better. So now you see, when it comes to running the same machine in cloud, then what happens is that there are few things that are building blocks of that machine. For example, if you start looking at it from here, right? Storage. Any machine, any laptop that you are running anywhere, right? That actually requires some storage because everything gets stored in there. It requires networking component, right? So you can connect with perhaps another laptop to internet that is required. Compute, which is CPU, memory, all that is required also, right? And once we have these three components available, these three basic components available, then on top of that, we basically create something like a laptop or something like a virtual machine. Now think of virtual machine like your like your virtual laptop, right? That we are virtualizing everything. Now, when we are virtualizing everything, then where does this physical infrastructure go? It actually goes to Azure, as you can see in infrastructure as a service. So compute, networking, and storage is provided by Azure. You don't see that. You don't buy that. You don't acquire that at all, right? So then all Bella has to do if she wanted to bring her website and running it in cloud was, and the easiest way was for her to go with infrastructure as a service, in which the entire machine comes up here and it runs as is. The only difference is that storage, networking, and compute is taken care of by Azure. So she doesn't have to buy any hardware. You look at it that way. She doesn't have to buy. Perhaps just go to a portal, create a virtual machine by a few clicks, machine is available, bring her website, and have it running there, is all that she has to do. And this is called infrastructure as a service. In this case, what Azure is providing you is merely infrastructure. So you can bring in your own machines that you were running in on premises, and you can run them as it is in cloud. So what have you changed? You have changed in a way that you are not having to maintain any hardware now. correct? So in infrastructure as service, only infrastructure is provided by the cloud provider. Then on top of it, the virtual machine you will manage. Operating system, which is Windows, Linux, you manage. So you can see green is you manage and cloud provider is blue, right? And then runtime, applications, data access, all that you manage. Now, in your laptop, what do you have typically? You have an operating system. In that, you might have basically a runtime. You might have applications, right? Many applications like Zoom, right, or this whiteboard or Office or whatever. And those applications might have their own data, right? So all that is managed by you. So once you start the VM or once you log into the laptop, you have all that. Azure cannot go inside and see what is happening inside that virtual machine. They cannot see because it is infrastructure as a service. Okay. So that is what it is. Only hardware is provided by Azure. Everything else you manage. You have full control over that. Right? Look at it this way. Only you know the credential to log into the machine. Even Azure doesn't know that. So you have full control over there. Now, if you were to compare this IaaS to on-premises thing now, you realize that on-premises Bella was having to do everything, right? Bella was having to do everything. And see if you have any questions. I'm actively looking at the chat. So if you have any questions, post the questions in the chat and I'll pick it up now or after some time. Okay. All right. So that is infrastructure as a service. That is the first step for Bella, which is the easiest for her. At least now she doesn't have to maintain the data center. She's happy with maintaining the machine. Perhaps she can buy she can get an Azure administrator, and that person would actually take care of maintaining all the administrative stuff of that, of that website. So mainly infrastructure as a service. What happens when you move from infrastructure as a service to platform as a service is that rather than infrastructure, rather than only infrastructure, Azure is now providing you the platform as a service. Now, you would wonder what is a platform? Okay, to understand that, let's do it this way. If you are new in IT, a very common architectural pattern that you would have to understand is called, this three-tier architecture. Is this three-tier architecture? So three-tier application, what they are, how do they work, right? A three-tier application in IT means that we are talking about Bella's website, right? It would have three tier when it comes to architecting that. Tier number one would be basically the web tier. Tier number two would be the app tier. And tier number three would be the database tier. If it is new to you, not to worry. Website, which is the front end, purely the front end, is to be hosted, right? That front end, website front end, would get hosted on the web layer in three-tier architecture, right? So this is one tier, this is two tier, and this is three tier. Application logic. Let's say Bella is offering some discounts, right? Based on if you're purchasing 5 items, then she would give you one free. So then that logic that okay, whether somebody is purchasing 5 items, then automatically basically adding up another item or adjusting the cost of the sixth item because that has to be free. All that is business logic. Application layer keeps basically that business logic. Okay. And then database layer, order is placed. Where does the order get stored? In the database. Somewhere there is a database. And if you have heard about, things like SQL Server or Oracle or MySQL, all these are databases. Okay. So all that data that is getting stored is your database layer. Okay. Now imagine if I were to do IaaS, how will I architecture this into the three-tiered architecture, that website of Bella into the three-tier architecture. What I would do is I would do it in this manner. All right, one machine and another machine. So another virtual machine, right? And third virtual machine. So I have one web server, I have another app server, and I have third database server. Three virtual machines. And since it is virtual machine, Azure is only providing you What? Azure is only providing you compute, networking, and storage. Everything else you are managing. Everything else you are managing. These three virtual machines you are responsible to manage, right? As long as it is infrastructure as a service. Now, platform as a service. What this does is that, what if I wanted to reduce my responsibilities to manage virtual machine, operating system, and runtime? I don't want to manage that. I want Azure to manage that for me. Because I'm just starting with three virtual machines right now, I might have one Azure administrator, and that person can take care of all the three machines. Tomorrow, as more and more user requests are coming up, I might need to have more web servers added to scale it, more application servers, right? And perhaps more database servers. More and more responsibilities would come up. You want to minimize that. And when you want to minimize your responsibilities, your administrative responsibilities to maintain this infrastructure, you choose platform as a service offering. With platform as a service offering, what happens is Bella can choose to run the same website, but now she also doesn't have to manage a virtual machine, as you can see here. Virtual machine, Azure is managing. Operating system, Azure is managing. Runtime, Azure is managing. So there is no virtual machine to be seen in that case. But what could happen is that, now Azure might say, okay, fine. This side you have IaaS implementation. On the other side, if it becomes PaaS, how you can do it is that all the web, all the web, all the website code, let's say front end code, and the app layer code, right? You basically package it into one service. You package it into one service, and you will get to the service. On the other side, the database that you are running, let's say SQL, you package it into another service. You choose another service for that, service 2 and service 1. Now, Azure would provide you these services, service 1, service 2, service 50, service 200. There are hundreds of such services. But when we say PaaS, you need to realize that what we are saying is, I want to get away from managing virtual machines myself, because every virtual machines I need to manage them. Can you give me a service if I have to run my database, let's say SQL Server or Oracle? Give me a service where I am only interested in the database and the data that it stores. I'm not interested in the virtual machines on which it is running, operating system on which it is running. I don't want to manage that. And that is exactly what PaaS is. What Azure would do is they would provide you a PaaS service. Let's say for the database, they would provide you a PaaS service. Now, rather than installing that database in a virtual machine, right, you are simply creating an instance of that service. And you don't see any virtual machine behind the scene. There is no virtual machine that you're responsible to manage. Azure would manage it for you. And that's why it is called that you don't manage runtime, you don't manage operating system, and you also don't manage virtual machine. And that is actually PaaS. Okay, that is PaaS. So for clarity, as you move from IaaS to PaaS, your responsibilities reduce. Cloud providers' responsibilities increase. Okay, and any day, if I want to go to cloud, I want to reduce my responsibility, right? Bella would want to reduce that responsibility. She would not want to have more Azure administrators or system administrators managing that. Keep it simple. That's why platform as a service. So platform, like a database, is offered as a service, okay, in which you can host a database. On the other side, a service is provided to you where you can bring in your website, your front end, and your application logic and host it there. Again, a PaaS service. So you just needed two PaaS services, and your architecture got much more simpler. Now there were no virtual machines to be managed. It was made simple with the help of PaaS. Okay, that is platform as a service. And now software as a service is actually the third thing here. If you have, if you have heard about Office 365, if you have heard about OneDrive, right? All these are examples of software as a service. Now, those old days we had to install everything on our machine. If I had a laptop, I would install Microsoft Office, Word, Excel, PowerPoint, etc. Right? Today we don't have to. I mean, it's all online. I can just open it in a browser and I can work on Microsoft Word, Excel. Well, for my convenience, if I still want to install thick client on my laptop, I can do that. I can do that. That's fine. But that is example of software as a service, where you are only responsible to manage data and access. Now look at MS Office. You create Word document. You only care about Word document. You don't care about how is Word installed, how is it configured, how is Excel working. You don't have to worry about that. What you care is your data and who can access that data, who can access that Word document, or who can access that Excel file, right? That is software as a service. Now, you look at it this way. You are moving in from on-premises to cloud. You have certain options. Okay, yeah, SharePoint as well, correct. SharePoint Online, for example. So SharePoint Online is another example. We used to install SharePoint on many, many machines. In the backend, there used to be SQL Server, a lot of instances of SQL Server databases. It would result into a lot more virtual machines. But now it is made simple. It is offered as a SaaS product. Azure manages everything, everything. You just basically create an instance of that for yourself. Okay, that is software as a service. Now, coming back to my point and to conclude this, when any business is migrating from on-premises to cloud, they have these three options: infrastructure as services, right, which is the most easiest, if you see, most easiest, right? Because bring in the same, exactly the same virtual machines, run them here as is, right? Very easy. But you might not get the full advantage of the cloud because you're still having to maintain those virtual machines. The better option is platform as a service. Okay, so you get rid of all the virtual machines, right? That is a better option. So always look for PaaS over IaaS, and then SaaS. Not everything can be packaged as SaaS. So the PaaS is the sweet spot. SaaS, only a few services would be there, right? Like Salesforce is a SaaS service, right? Some services, let's say you are running a very, very old, very, very old traditional application for which there is no PaaS service available in Azure because it's pretty old and Microsoft doesn't care creating one PaaS service for that, right? Because it is not a good use of their investment. In that case, continue to run it on IaaS in a virtual machine. Continue to do that. But whatever can be migrated to PaaS, do that. So that is infrastructure as service, platform as service, and software as service. And as you move from left to right, your responsibilities go down, cloud providers' responsibilities increase. Okay. Now Bella is very happy that she's looking to basically perhaps take a mix of IaaS and PaaS when it comes to migrating the website, etc., or any other solution that she was running. And now she has completely gotten rid of this on-premises setup where she had to manage everything. Okay, so she's very happy. She's very happy with that. Any questions at this point? Any questions? Okay, so you guys are not asking many questions, which is in a way good, but I think would be even better if you have some. If not, it's okay. You can perhaps post it later as well. Okay. Now, okay, there is another thing which I want to cover in this session, and let me just go ahead to do that. And maybe, let me just come back to show you what have we covered so far from here. So we basically covered the case study, right? We covered Bella's boutique case study here, and then then of course we we basically talked about cloud computing, its benefits. We talked about key terms such as economies of scale, pay as you go, capex versus opex, right? We talked about all of that. We talked about cloud models, public, private, and hybrid. And we talked about IaaS, PaaS, and SaaS. One last thing which I want to talk about in this section, in this part, is Azure core architectural component. and it is a very important thing. Okay, so let's dive into that last topic for today. And in the meantime, if you have any questions. Okay, so there is a question from Vasanthi Krishnan, eager to know about how runtime plays a role in the cloud. Now, see, runtime could be if my application is an ASP.NET application, for example, right? Then .NET framework is required, and that .NET is a runtime in this case. Okay, .NET is a runtime. Now, if I wanted to run this website, let's say Bella's website, it is built using .NET. Okay, now if it is built using .NET, and if I choose IaaS, I will have to install that runtime myself. I will have to install that .NET framework. On top of that only, my application can be deployed. And if it were to be a Java-based application, then of course, Java would have to be installed, and that is the runtime. Okay. Now, when Bella chooses platform as a service, then IaaS, then she doesn't have to worry about installing runtime. She doesn't have to install .NET or Java runtime environment. No, it would be managed by Azure. All you need to do is to tell Azure, right? Azure would like to know, hey, Bella, you're bringing in your website. Tell us, is it a .NET based website or is it a Java based website? You tell that, it will automatically, behind the scene, create a VM, install everything, and keep it ready. You don't see the VM. Okay, by the way, you don't see the VM. So that's how it would work. Now, uh, which service do big companies like banks choose? So see, we have not spoken about services yet. We will talk about a lot of them. But just to answer, virtual machines. We talked about virtual machine. There is one compute service is used by almost every organization, be it bank, government. They use that, right? On the other side, when it comes to PaaS services, right, we have services like, I mean, I can name the service, but it wouldn't make any sense to you at this moment. Okay, so I can say, things like there is basically this Azure App Service. It's a PaaS service. It lets you deploy your websites without you having to maintain operating system. Okay. For SQL, I can tell you that there is a service called as Azure SQL, which is a PaaS service, which lets you run SQL Server database without having to worry about virtual machine installing SQL. No. Okay. So that is that. Okay. Okay. Somebody says three-tier architecture part was a little difficult to understand. No problem. We have to break it up. Okay, we'll go step by step. You don't have to basically take everything and understand everything in one go. Revisit the recording, revisit the video, but just keep it simple that any application we need to design, there is a front end, the website that you see when it loads. Okay, that is the front end. It has to be hosted somewhere in a web server. Okay, like Tomcat, IIS. That is that layer. That is web. Application layer is more business logic, where business logics are done. For example, to calculate discount, if the product ordered are more than five, then there is 50% discount on the sixth one. This is business logic. It is separate from your front end. Front end is merely displaying. This is application logic, which is business logic, which is your middle tier. And finally, where does the data get stored? In the database. In the database, that is your database tier or the third tier. So we call it three-tiered application. Okay. All right. Now, one last thing to cover, which is Azure architectural components, right? Now, what happens is that you need to understand how is Azure structured. Okay. How is Azure structured? And again, to make it easy for me, so I don't really have to do a lot of whiteboarding here. What I want to do is I actually want to bring this thing here on the whiteboard, and it will become so much easier for me to explain to you. Yeah, just give me one moment. Okay. Yeah, so architectural component, we will get to that. In the meantime, take a look at this image that I pasted on the that I pasted over here. Okay, right. That is good. Yeah, that's good. All right. So, see, now what happens is that although cloud is providing you the benefits, right, such as high availability, scalability, right, security, and all that, how it is doing that, it is important to understand that. So, very quickly, take a look at this. We call it that it is global. This service is global, right? So, how Azure works is that Bella was located somewhere in India, right? The data that she's managing is not so sensitive, but perhaps she has, some personally identifiable data or PII. She has to take care of that. Perhaps the government in India would say that any data belonging to the Indian citizen cannot go out of India, right? To address that requirement, if Azure has to really work in India to respect that regulation, that policy, Azure must ensure that they have a data center firstly in India where they can keep all this data because they are not allowed to take all this data outside. In other words, it means that you are basically making it possible for the people in India or elsewhere to deploy their applications, to bring in their applications, same like Bella. But you're telling them that since I have a data center in India, I'm not taking your data anywhere outside. It will remain in India. For that, they have to have data center, right? Many other countries would be having similar kind of regulation. You go to banking industry, you go to defense or government sector, the requirements would become even more stringent. To respect that, what Azure has done is that looking at it globally, right from the top, there is this notion of geographies at the top. So the entire Azure infrastructure, it is basically divided into what is called as geographies first. Okay. So Azure has geographies to honor data residency and compliance requirement. Exactly what I spoke about just now. Okay. Within geography, then they're divided into four. One is Americas, another one is Europe, Asia Pacific, and Middle East and Africa. So they divided that into these four geographies because Europe would have their own basically regulatory requirements or compliance requirements, and they will be different from how it is in America. That will be different from how it is in Asia Pacific, etc., etc. So therefore, divided into four different geographies. So geographies, how many geographies are there? Americas, Europe, Asia Pacific, and Middle East and Africa. Four geographies. Okay. Then, if I were to double click on Asia Pacific, so when you double click on geographies, what happens is then comes region. So the first thing that we learned is geography, right? Second thing we are learning is region. And region is always within a geography, as you can see, right? Is always in a geography. Every geography has a number of regions. And just to take an example, in Asia Pacific, Southeast Asia is one region, which is pretty much here in Singapore, right? Within Asia Pacific, there are multiple other regions which are in India. Okay. There are many other regions which are available even Australia. All those are Asia Pacific regions. And I'm just taking examples of two, Southeast Asia and East Asia. Southeast Asia is basically Singapore, and East Asia is Hong Kong. Okay. So they are defined as region. Now, what happens is within region, then, and I'll come to this region pairing, whenever you deploy something. Let's say today I decided to start my own business and I needed some compute, right? I choose Southeast Asia region. I go to Azure portal. I choose Southeast Asia and I deploy that. What happens is Azure automatically takes a backup of that here from Singapore, and it actually replicates that backup to East Asia automatically. So every region has a paired region to make sure that there is high availability. Your data gets replicated automatically, okay, which is to increase high availability. If you don't do that, there is something wrong. Let's say the entire Singapore is down for some reason, my data would be gone, my application would be gone. To prevent that, they do that. Okay. Now, if you were to double click on Southeast Asia, then what happens is every region has a number of data centers. Every region has a number of data centers. As you can see in Southeast Asia, I'm depicting 6 data centers. Data center number 1, 2, 3, 4, 5, 6, right? So geographies have regions, regions have data centers, and in the data center is how you basically deploy your resources, whatever you are creating, perhaps a virtual machine or whatever, okay, is how it works. So just keep these couple of things in mind as well for this session. Of course, we will double click on this in the next video because this is very fundamental to understand how does high availability work, how does fault tolerance work, etc., etc. We will understand that using the same graphic in the next session. But for now, I will leave you with geography, region, and then within that, there are a number of data centers, is how these architectural components are structured. What we are covering today is uh, Azure architectural component, as you see on my screen here. So we'll talk about Azure architectural component, and in there we will again take a look at region and availability zone, right? So yesterday we were talking about some high level things, right? For example, a geography and then regions in there, then data center. So we will double click on that so you understand some of the important concepts out there. Okay, we will do that. And thereafter, we will talk about subscriptions and resource groups. Because see, in cloud computing, it is all about leveraging the compute, the storage, the networking that cloud provider is providing you. Leverage that to create your own resources, right? And you can create different types of resources. You can create databases, right? You can basically create things like you can create things like applications, right? You can create data lakes, for example. You can create virtual machines. So there are so many different types of resources that we're going to talk about. Okay, so we need to create instances of those resources in cloud. Okay, so we will understand before we get there to create instance of any resource, we will understand how are these resources arranged, organized, right? Remember, we were talking about, and we are still continuing with Bella's boutique example, right? That we started off with. And you know by now that she was running a website, right? Like a three-tiered website, front end, application layer, and then basically the back end. So she wants to perhaps create, let's say, virtual machines to start with very basic. And for that, we need to understand where do these resources sit, etc. So that's where the subscription and resource group is going to help out. Okay, so we will talk about that. And then we will start going into the topics. We will first talk about compute and networking related topics. So when we talk about services, you can basically categorize the services in this manner that some of the services could be compute type. And I've already told you what is compute. What is compute? Can you tell me in the chat window? What does compute include? Very quickly. Don't take too much of time. Compute. So you tell me and I type in here. Compute. What does that include? Watching the chat window. Okay, so I think there is a little more delay than I expect. Calculating. Okay, so basically, compute means the capacity to run your resources, right? It could be CPU, it could be RAM, right? In terms of memory. So that is, yeah, correct, Sujin. CPU and memory, and basically the power to manipulate, power to process, right? Some workload. So we'll talk about compute types. We'll talk about various application hosting options and virtual networking. Now, see, networking, there are many people over there who have expertise in networking. Some of them, they work in on-premises type of a setup, right? I mean, prior to cloud type of a setup, where they basically get to deal with a lot of networking related devices and hardware and equipments, right? Such as router, such a router and gateway, etc. In cloud, we don't really deal with the physical ones. We deal with the virtual networking resources, right? So we will talk about what are some of the key virtual networking resources that you have in cloud and that you require to spin up any resource, for example, right? So you don't need to go as deep as somebody who is an expert in the networking would have to go. We don't have to go that deep. So we can have the basic knowledge of networking, and with that, we are good to do so many things on cloud, right? So it is basically virtual networking is what we will talk about. And then number three would be around storage. So we will see what are the different storage options that we have, different storage options here. Now, so we will talk about a number of storage services. We will talk about redundancy options. So redundancy simply means that how would Azure make sure that if I put my data into Azure, imagine if Bella is putting in all the inventory and all the payment and invoices data on Azure, how would Azure guarantee that her data is safe, right? Even if, let's say, there is an outage, there is the whole India-wide outage, how will Bella make sure, how would Bella be assured that her data is still available and accessible, she doesn't lose the data, right? So what are the different redundancy options that make the copy of the data or replicate the data? We will talk about that, okay? And then file management and migration. And then the fourth part, is actually mainly around, as you can sense already, this is mainly around security aspects of things. As a security is very important in cloud because we are no more talking about basically a data center, right? Data center which is physically secured because it's in a building. You have a perimeter, nobody can enter in, and since nobody can enter in, you basically have that that clear filter that that is your security parameter. But in cloud, since we are accessing resources over the internet, right? So we need a little more stringent security because it is open up, it is open for everybody. So we need a more stringent, more robust security mechanism that can really make anybody who is putting in their resources and data on cloud feel safe, right? So what are the resources for that? We will talk about that. Okay. So let's get started now. Yeah, so that will be the agenda. Now, what I want to start with is firstly the architectural component. Okay. And those architectural component, as I mentioned, you say imagine Azure being basically a global cloud provider, right? It is a global cloud provider. And then what happens is that they have their own data centers and many places in many different countries in many different geographies, right? So as we were talking about yesterday, and to go back to that very, very quickly, there is this concept of geography first, right? So that's how Azure is divided, okay? And in the geography, as I talked yesterday about, we basically have four geographies, right? One being America, another being Europe, and then another one being Asia Pacific, all right? And then we have Middle East and Africa, okay? Now, why do we need these various geographies? This is also important to understand. Why do you need these different geographies? These different geographies are needed to meet the regulatory requirement, right? Legal requirements and compliance requirements. Because across every country, we have finance industry, right? We have government sector, we have retail industry, right? We have insurance industry, and every other industry has its own policies and rules and regulations uh, that they have to follow within their geography. So, for example, Europe, European Union, they might have their own basically set of policies and regulations, and anything that gets deployed in Europe region must adhere to those policies of the Europe region, right? So in that way, we basically divide it into the four part, and each and every geography would respect the rules and regulations and the compliance requirement of that particular given geography. Okay, so geography, there are four geographies to meet compliance requirements. Okay, keep that in mind, right? Now, if I were to double click on Asia Pacific now, then within each geography, we have a number of region, right? So I will just give you one example that within Asia Pacific, for example, we have a region which is called which is called Southeast Asia, and the other one is East Asia. So Southeast Asia is pretty much Singapore, and East Asia is Hong Kong, as I was telling you quickly yesterday also. Now, the important thing here to understand is you have geography, then you have region. Every geography has a number of regions. Okay. Now in India, now in Singapore, Singapore is one region in itself. But if you talk about India, right? Say Singapore is one country, India is another country. But in India, you can have many more regions. So don't equate the region to a country, is what I'm trying to tell you. You might very well have basically a region, right, which is called South India, and you might then also have a region, you know, which is called let's say North India. So region doesn't mean country. Don't equate that with a country. That's an important thing to understand. But in case of Singapore, it happens to be a small country, so just one country and one region. Hong Kong, the same. Okay. Now, the other important thing that you need to understand is from the availability perspective, right? We were talking about the fact that cloud is more available. Now, if I open up a business here and I choose to deploy my resources here in Singapore, what Azure does is that it automatically it has a mechanism, right, by which it can actually, it can replicate some data between the two regions. Every region in Azure is actually paired to another region, okay, within the same geography. So Southeast Asia, East Asia are part of the same geography, right? Now, this link is actually called region pairing, region pairing. So what region pairing does is that it is connecting one region with the another region. Okay. Now imagine tomorrow the whole of Singapore is down. Since your data was replicated from this region to the other region, you still have Hong Kong up, right? So you can get the data from Hong Kong. This can be restored, and vice versa also. Okay. The other benefit of region pairing is also, right, let's say if both of the region go down, then at least Microsoft knows that rather than getting confused about which region to focus on, they would actually prioritize any one region out of this. Okay. So imagine that there are 50, 60, 70, or 80 regions, right, across the globe. What they would do is that, and everything is down, so they are not going to focus on each and every region first. They would actually focus on one region out of one pair. So for example, if the pairing is between Southeast Asia and East Asia, they will pick any one, and they will focus on bringing that one up and online first on priority, because they know one is up, then at least they can start serving the customers. Okay. That is another thing. And the third thing with region pairing is that, what happens is, in case let's say, okay, or maybe for now, let's keep it simple. So there is region pairing, which is a link between two regions. Okay. So you can basically implement something like data redundancy from one region to the other region. That is region pairing. And similarly, you have a number of regions. And now, if I were to double click on Southeast Asia, right now, I will double click on Southeast Asia. Now, what happens in case of a region? If you double click on a region, then what happens is that there are data centers in every region, and this is important. Huh? So pay attention to this. And there would be two important concepts that you're going to cover right here. And now we double click on Southeast Asia. There, the way it works is that this is Southeast Asia. Now, in every region, there would be basically number of data centers. Every region has number of data centers. Now, in this case, let's say, and I'll just take an example. They can be more also, but let's say this is data center number two. Okay, this is two, this is three, this is four, this is five, and this is six. So we have six data centers. Let us just take an example. There could be more also. Now, every region, as you see, it has a certain number of data centers. Okay. And then what happens is that as you are deploying anything, right? In our case, we were basically talking about Bella's website. Now let's say Bella decided to deploy something in one of the data center in one of the region, right? Imagine she actually created something like a virtual machine. Then what happens is, let's say virtual machine is deployed here in this data center. Now what happens? If this data center goes down, there is a possibility, right, that the entire data center might go down. So what Azure does is that within the region itself, as there are multiple data centers, those data centers are actually connected to each other. They are connected to each other. Okay. Like number one is connected to number four, number two is connected to number five, number three is connected to number six. And this pairing of data center is actually called as, and this is an important concept, right? This pairing of data center is called as something that is known as availability zones. Availability zones. So that means we have three availability zones here. We have AZ1, AZ2, and we have AZ3. Three availability zones. So thereby you know that when we talk about availability zones, it's nothing, but it's basically a collection of at least two data centers, right? And why do we do that is if your data is deployed in one data center, and for whatever reason, power failure or something goes wrong, right? Rack failure, hardware failure, your data is actually replicated across not across two data centers at least, number one and number four. Now, when that is done, even if the entire data center goes down, you can still, as you can imagine, you can still uh, get the data from data center number four. If four goes down, you can get the data from one. Okay, so this is an important concept to understand. Availability zone consists of two data centers. If you replicate data, imagine web server, right? For the Bella's website, we have two web servers here. What I decided to do is I decided to now put one web server here in this data center and another web server here in this data center. So one in data center number one and the other in data center number four. Now what happens is even if one of the server goes down, let's say data center number one goes down, there is another there is another web server which is still there, right? It will keep on taking requests when somebody goes to her website, and it will keep on providing the response, right? So as long as you are making use of availability zone, even if entire data center fails, your application would still be available. It is very difficult to achieve in on-premises setup, right? But in case of cloud, it is built uh, right, right from the bottom up. Okay, so that is availability zone. So now, from the exam perspective, they might ask you, okay, tell us what do you use availability zones for, and what is it, and why is it useful? So it is useful in the cases where even if the entire data center fails, right, your application would still be available. So it can actually withstand the failure of entire data center. Is how you have to see that. Okay, so remember that this is availability zone, and this was one of the concepts that I wanted to come to. And why do we create availability zones, right? That is another thing. So maybe let us very quickly try and understand that as well. Let's say this is Singapore. How Azure would do the arrangement of these data centers is that, let's say somewhere in the north, south, east, and west. Okay. What Azure would do is that, they will place data center number one and perhaps data center number, four here. They will place data center number two and data center number five somewhere in the west, for example. And let's say data center number three and data center number six somewhere on the eastern part of Singapore. They do it this way because imagine tomorrow there is a calamity, right? There is basically a storm or there is an earthquake, and that actually affects this entire area gets affected. Now, even if this entire area is affected, and these data centers were not accessible anymore, in that case what would happen is that you still have data center number 2 and 5 available, you still have 3 and 6 available. So these data centers within a region are not created next to each other, right? Because then that will defeat the purpose in case something were to happen in a small area. So they basically keep it sparsed, they basically keep it distributed uh, across a wide area. Okay. And that way, even if one particular location is affected, it is fine. Your data centers would still be up, your applications would be up. Now, just correct, one correction that I would make here is that if one is here, one second. Yeah, so in the north, I was placing data center number one and data center number four, right? So we can say that perhaps data center number one and four are not together, but data center number one and two are together. Okay, because availability zone comprises of data center number one and four. Therefore, we will not keep it together. Okay, so one goes down, fine. Four is still there, right, somewhere else. And all these data centers they are connected using high speed fiber cable. So they are all connected to each other. So therefore, we don't have to worry, right, that hey, how fast the data transmission would be, whether there would be response, there would be latency issue. You don't really have to worry about that. So because these data centers are connected, and this connectivity between data centers, right, or from one region to the other region, or between the geography, it is actually called as what is called as Microsoft Azure backbone. So we basically call it Microsoft's own backbone, right? Connectivity backbone, where they have themselves laid down the fiber cable, right, at the global scale, at the humongous scale. And those are the cables which are basically connecting these regions together, these data centers together. So you don't have to worry about latency. It is not over the internet. Okay. So that is backbone. That is the concept of backbone. Now availability zones you understood, which is to withstand the failure of entire data center. Okay, one data center goes down, no problem. Okay, there is another concept which is called as availability set. Okay, right. Now another concept to understand is availability set. So this is also important concept to understand. Now, to withstand the failure of entire data center, we have availability zones. We understood that, right? And typically, there are three availability zones in any region. Three availability zones, right? Like in case of Southeast Asia, as we're double clicking, you could see AZ1, AZ2, and AZ3, right? So you could see that. Now, there would be at least three availability zones. So you just have to make sure, we just need to make sure that when Bella is deploying, let's say three web servers for her website, she actually puts one web server in availability zone one, other web server in availability zone two, and the third web server in availability zone three. And thereby, she would have actually distributed her application across multiple locations. And even if two locations go down, one is still up. So that's how this availability concepts get applied when you are architecting that. So that's how you have to see that. Okay. Now, the concept of availability set is how about within the data center? Now I'm talking about a data center, because sometimes what might happen is that something might fail in the data center also, correct? Something would fail in the data center, and what would happen is the rack, right? Rack actually got down. Something went wrong, right? Power supply got interrupted. The cooling got interrupted, and due to that, one particular rack in the data center failed. Okay, so there is also this mechanism that is called as availability set, and what it does is that and this is again an important topic to understand even from the exam perspective and otherwise from the cloud perspective. Data center is not created in such a way in cloud or in Azure that all the racks are put together. There is one single power supply, right? There is one single network support, one single cooling unit. No, the way Microsoft creates the data centers, every single data center, is that they basically segregate it into multiple physical locations within the data center, within the same building. Okay. And those segregations are basically called what we refer to as fault domains. Fault domains, or FD in short. Okay. So we can call, this is FD0, this is FD1, and this is FD2. Fault domain. Okay. Now, the thing about fault domain is that every fault domain has its independent cooling, independent power supply. And if one fault domain goes down, there are other two still functioning. If the power supply gets interrupted for fault domain zero, only fault domain zero is down because one and two they have their own redundant cooling and power supply, which is independent of other three. Okay. Now that is taken care of now. So within the data center, if one particular piece of rack fails, it is affecting only that particular fault domain and not the others, right? Now, within the fault domain itself, sometimes what would happen is that within that fault, okay, you can look at it this way, that you have a big building or you have a big apartment in which you have multiple rooms, and every room is a fault domain, and every room, but unlike the typical home, the power supply, cooling, etc., is independent for every room. So even if the main supply is cut, it is only cut for one particular room only, right? So look at it that way. And then after that, every room has its own infrastructure also, right? Like rack, storage, networking equipment. Now, there what happens is, out of all that, within one room we are now talking about, right? Or within one fault domain, we might have a number of racks, right? We might have number of racks. And now what might happen is that at any point in time, one rack might go down. And imagine if Bella's web server, hi Amu, yeah. So if Bella's web server is deployed on this rack here, on this rack here, the one that I highlighted, okay? Then what happens, right? Then what happens, because the entire rack is failed, the rack was storing that particular web server for Bella's website, okay? There has to be a mechanism that is automatically replicating this data from one rack to the other rack, okay? So how Azure handles that is that it then basically gets divided into what is called as, so number of racks, they are basically comprised together. And then this is basically called as what we refer to as update domain. So update domain, and here we were talking about fault domain. So what is update domain doing is that it is basically creating a copy of that virtual machine, okay, of that virtual machine that Bella has deployed. And what it will do is that it will basically, one second, yeah. So it will basically maintain a copy of that over here also, over here. So now to basically make it a little more neat, if I were to say that this is a fault domain, and in that fault domain, these are basically the update domain, and the machine is basically deployed here. A copy of that machine is also running here with the help of update domain. So now what happens is, when one rack goes down, let's say this entire rack went down, no problem. We had the copy running in from here. So we still have the website up and functioning, no problem at all. Okay. So this is the concept of update domain. Now imagine, if let's say if Azure were to do software updates, software patches, etc., right? What do they do? The way they do it is that they will focus on one update domain at a time. At any point in time, they will go to one update domain. They will apply patches, update, etc. And if the servers have to be restarted, they would only restart to one update domain at a time. Okay, so one update domain can be restarted. You still have a copy on another update domain, right? So what would happen is that if one copy was running here, the other copy would be running in another update domain here. Okay, so basically it's distributed across. It is distributed across update domain is what I'm trying to say. One copy of VM here and other copy of VM here. At any point in time, only patch or only update one update domain. So to close this topic, we have availability set where the entire data center gets divided into what is called as fault domain. Okay, and then thereafter, every fault domain is then further divided into update domains. Right now, even if the entire update domain is down, let's say update domain 0 is down, and you deployed something on update domain 0, what would happen is that a copy of that virtual machine, you will have option, right? You will have option, or Bella would be given option. Okay, you are choosing to deploy that in availability set, whether you want to replicate your machine across update domains or not. If you want to replicate it across update domain, how many update domain do you want to replicate it across? Right. So she can choose, anywhere from 0 to I guess 21. I think there are total about 20 update domains available that you can choose when you're creating that. So then copy will be spread across those update domain. Now let's say you have chosen 5 update domain, and there are 10 machines that you're deploying. So it would deploy it in this manner that that the first machine would go to update domain 0, second to update domain 2, 3, 4, 5, and then again back to update domain 0, update domain 5 or 6, right? So 1, 2, 3, 4, 5, 6 is how it will go. So even if one is down, it doesn't matter. We still have some servers up which are running on other update domain, right? And we know that when there is patching or whatever, only one update at a time will go down. Okay, and similarly, only one fault domain will go down. Microsoft will not do it this way that at one point in time they have taken all the fault domain down for update. No, they will go one by one. Okay, so what should you be clear about by now is availability set, which is to withstand the failure of a particular piece of hardware or a rack within the data center. That is availability set. That is prevented with the help of availability set. Okay, availability zone. What if the entire data center goes down? Then availability set cannot help because it is working at the data center level, right? If that happens, then we have availability zones because availability zones replicate our data or our resources from one data center to the other data center. Now, tell me this. If I were to create a machine, right? Let's say Bella just want to create a web server and she wants to understand as to how her virtual machine should get deployed in Azure in a way that makes it most available. What are the various options that she has? Okay. So it works basically in this manner that I choose, let's say, Southeast Asia region. That okay, go and or maybe not Southeast Asia, right? Let's say South India. And in South India, she basically chooses the South India region. And then you don't get to choose data center, right? So when somebody is creating this virtual machine or this web server in Azure, they don't get to choose which data center do you want to deploy that to. No, you only choose a region. So I choose South India. And in that, it will automatically, send it to any data center that you don't have a control over. So she said, let's say, okay, in Southeast Asia, only maintain one copy of my VM, no redundancy at all, right? Only a single VM. When you maintain a single VM, you don't use any availability zones, you don't use any availability set, right? Then what happens is, how much availability do you get? You get availability of 99.9%. Your virtual machine is 99.9 percent of the time available across the year. Across the year, okay? No redundancy, right? No replication, only one single VM. And if it was a bad day, that piece of hardware, the rack where this machine is stored, goes down, application is down. Okay, that is option number one. Now, option number two, we we make it a little better. We start using availability set. At least use availability set. If data center one piece of rack goes down, my application should still be up. So then she basically starts using availability sets. And you know what happens with availability set, that it will get replicated. When it gets replicated, her machine is now basically across two different fault domains, 0, fault domain 1, and also across update domains, 0, 1, let's say. Now, since machine is replicated, one goes down, other is available, other goes down, this one is available. Now the availability would increase from 99.9 to 99.5. Okay, increased. And if you look at it, it is actually a 50% increase from the last time. 50% increase. If I were to say that 99.9 means 20 hours of downtime, although I might have to check exact hours that it translates into. But if it is 20 hour, 99.95 would bring it to half, which is 10 hours only. Okay. In fact, 99.95, basically brings it down to a couple of hours only. Okay. Now she wants, no, I cannot afford even that. I want more availability. Then what happens? Okay, she has an option to now use availability zones. So now use availability zones. So then what would happen is that, across data center, but across availability zones. So AZ1, AZ2, and AZ3, right? And then across different data centers. Once she does that, this time the kind of availability that she gets is 99.99, which means, that her virtual machine would be available throughout the year for only for less than 1 hour, is what it means. So now you realize, somebody says, okay, I want my application to be available all the time. My website should never go down, like Amazon website, like Netflix. So behind the scene, this is how these concepts basically work. Okay. And if, let's say, availability zone, now she says, what happens if the entire region is down, right? Because availability zones are within a region across data center. Then what are the options? Then you have other option, but then that would be basically between the region. So you replicate the data between different region 1, region 2. Let's say India South and India Central. So you keep one machine here, you keep one machine here, but that will cause some latency because now they are far apart. Okay, so this is how it basically affects that. I hope this was clear. So this is all you need to know from the availability perspective. Okay, right. I will now move on. The other thing that I want to talk about is hierarchy, resource hierarchy, which is an important concept here. And just to go back where we started, uh, we have covered basically regions and availability zones. This part we have covered, and now we are talking about subscription and resource groups. Okay, right. Now let's talk about that here. So now we understand about resource hierarchy, resource hierarchy in Azure. Now imagine, now Bella is talking to her friend, and she says, okay, we have to start provisioning the resources in Azure. Okay, where should Bella start, or where should a typical organization start to think about, right? How would that basically come in, is what we are talking about. And that's where you need to understand resource hierarchy. What happens is, Bella goes there. Bella's business name is Bella's Boutique, right? Bella's Boutique. This is her business name. What happens is, the first thing that Bella has to do, the first thing is basically to create a tenant in Azure. Create what? A tenant in Azure. Remember, yesterday we talked about the fact that public clouds are multi-tenanted, right? So we need to create tenant in Azure. Now, she needs to create tenant, and when we create tenant, what happens is that one directory gets created, and the directory, basically goes like this. The name of the directory would be something like this: Bella at on Microsoft.com. So this is how that directory would basically look like. Bella is the name of the company, right? Sorry, Bella dot on Microsoft.com. Bella dot on Microsoft.com. So this is the directory that gets created. Now, by doing that, if we have Bella's business on one side, right, we have maybe Dipanshu's business or your own business, Microsoft can then separate these two by this tenant. And that's why we say that the cloud is multi-tenanted. It is multi-tenanted because it can actually then segregate across these directories. Okay. So this thing that we created, this Bella's boutique that we created, it's basically called as a directory. So keep that in mind. This is a directory. First thing that we need to create is directory. You go to Azure, you sign up, you provide your organization name. The first thing Azure would do is to create a directory for you, right? Now, once the directory, once the directory is created, then what happens is you have basically something available here, which is by design, that is called a root management group. So there is this concept of management group, right? And this is the root management group. So there are two types of groups. You can say that one is a root management group, and the other ones are basically the normal management groups. Root management group would always be one, and normal management group you can create as many as you want. But why would you create? What is the use of management group, right? Is what we need to understand. So management groups are, is basically a concept that we use. See, in any organization, as Bella is growing the business, right? She might have basically the sales organization, right? She might have marketing organization. She might have IT, or she might have IT organization. So what she can do by management group is that, these different business units she can represent using management group. Let's say for IT there is one management group. For sales there is another management group, and for marketing there is another management group. Now, all these management group, you see, all these are normal management groups. Okay. Why we do that is that, you see, if you look at it from the business perspective, and I would like to add that business perspective to open up your mind. If you are, let's say, a fresher student and haven't worked in the industry, see, every time you are spending money, you are provisioning services on Azure, you have to pay money, correct? You have to pay money. The budget actually comes in from somewhere, right? If you're deploying a sales application, the sales team would be providing you the budget, and you basically need to spend that here. So all the resources that you are spending money on, you can actually put them together into the sales bucket. It becomes your management group. So everything sales related is here in this management group. Everything marketing related is in marketing. Everything core IT related is in IT, is how this concept works. So you are able to segregate these resources separately. And then you can see, okay, at the end of the month, how much have I spent on sales? You can just choose sales management group and it will tell you how much did you spend. Okay. So this is for better organization of various resources that you deploy in Azure, is what we use management groups for. And note, all the management group, they actually roll up to one single root management group. So every directory that you're creating, every business would have a one-to-one mapping between directory and root management group. One directory can only have one root management group. Okay. But inside that management group, then you can have multiple management groups created, which are normal management groups. And in fact, then you can also say that, okay, within marketing, I want to create another management group. Then you can nest also. You can do the nesting also of these management groups, right? Let's say marketing one and marketing two. So we looked at directory, we looked at root management group, and we looked at management groups. Okay. Now, once you have created the management group, you are you need to create something which is called as subscription. Azure subscription. Okay, you must have heard about Azure subscription, definitely, that there is a free one available, there is a paid one available. Subscription is a mechanism by which you are paying Microsoft for what you are using. Okay, so you don't have a subscription, you can't create any resource because Microsoft cannot charge you. So let's say inside sales, as I go down, now we have basically subscriptions. So I have I have subscription 1 and subscription 2 in here. Now, once I have subscriptions, then my life gets a lot more easier because then in every subscription, I can then start deploying resources. Okay. And every subscription would have its own monthly billing on a monthly basis. Azure would charge you based on the subscription. Every subscription would have one billing. But then let's say there are hundreds of subscriptions. For example, in sales, I have two subscriptions. I don't want to see individual billing, but I want to see the combined billing of these two subscriptions. I can actually go up to the management level, management group level, and I will see the complete billing from subscription one and as well as subscription two. Okay. And once you have subscriptions created, then in every subscription, you can then create what is called as a resource group. Resource group, let's say resource group 1, resource group 2, and resource group 3. And within resource group, you then create actually the resources. So for example, we were talking about, hey, virtual machine need to be created. Okay, virtual machine is created. Here is the virtual machine. So now if you go from bottom to the up, these are actual resources that you're provisioning. These are actually the actual resources that you're provisioning. Okay. But then resources are to be created inside a resource group. So you need to create a resource group, which is a logical grouping of resources. Okay. And that resource group sits in a subscription, in any one subscription. That subscription rolls up to management group rolls up to root management group, and then on the top you have a directory. So this is the structure that you need to keep in mind. Okay. Now, what I want to do is to make this point as well, this point also a little more clear to you. I actually want to bring in uh, this graphic here for you. So you can then reference it later when you are having access to the whiteboard. Let me do that. Okay. Yeah, so putting it here. Now you see, you have on the top management group, but before that you have root management group also that you know and directory. But it starts with management group, then subscriptions, then resource group, and then resources. Now, the thing about, or a couple of other things here is that as you can see, I have these three resources in one resource group, as you can see, right? A resource group acts as a group of resources. If I wanted to delete all these resources together, rather than deleting every resource one by one, I can just go to resource group and I can delete that resource group, and everything within that will be deleted. Okay. If I wanted to see how much have I spent on these three resources combined, I can actually just check the pricing and spending at the resource group level. That's it. I'm done. Okay. So, or I can go at the subscription level also. Okay. So keep that in mind as well. So that is the resource hierarchy in Azure, which is important for you to understand. Yesterday, we have already covered, as you know already, we have already covered these two. These two. Today, I would be starting from compute and networking. Okay. I'll do a very quick 1 minute recap of this thing, and then I will take you to the portal so that the things that we talked about yesterday, when it comes to architectural component, right? Things like directory, root management group, subscription, resource group, all that we will see today in the portal. Okay, so we will see that live or in practical, and then we will get to the compute and networking related services. And finally, we will talk about storage related services. So see, this is basically all about services, various services in Azure, right? And then finally, at the end of the session, we will perhaps talk about identity access and security. Okay, depending on we see how much time does it basically take. So uh, let's do that. Before I begin, right, I want to take you back to this screenshot that we were discussing yesterday. That in terms of the resource hierarchy, we talked about the fact that we have basically on the top, we have firstly what is called as a directory, right? we have a directory. So if, let's say, Bella has created a directory in Azure, right? So that would basically look like this: Bella at the rate on Microsoft on Microsoft.com, right? So that is how that directory would look like. And then within directory, we will have management group, as you can see here. And then within management group, we will have subscription, resource group, and then resources. So let us first see the structure in the in the portal itself. Okay. So now let me go to Azure portal and I'll bring it in here. So see Azure portal, just say portal.azure.com and you will be brought to Azure portal. Okay. Now I already have an account here, and then I logged in. Basically, what you can do is that if you just want to create an account, just go to portal.azure.com and sign up. And after you sign up, right, an account will be created based on the email ID that you have, and then you would basically be having uh, uh, you know this access to this Azure portal. And if you want to try out, right, with new, let's say, if you just want to try out provisioning the services, etc., then you can also basically get you can actually create a free subscription, right, which would ask you for the credit card, but as long as you have that, it will give you 200 USD of credit that you can use to basically provision resources. Okay. Now here, the first thing that you see is, let's say, when I come here to the account, I see switch directory, right? So let me just first click on switch directory here. I want to show you the directory, which is actually the first thing that we spoke about. So you can see that this is my default directory. So once I onboarded using my personal email account, it and which is basically structdt@hotmail.com. So what it did is that it basically created a directory or a domain which is structdt@hotmail.onmicrosoft.com is what it created, and that you can see right here as well. So this is actually the directory, and that is created. Okay. Now every organization would only have one directory. Remember that as well, right? Now, then after that, within directory, we will now take a look at management group. So let me just go back to the portal, and now let me show you management group. On the top of the portal, see, this is Azure portal, right? If you click on Microsoft Azure, you will be brought to the home page. If you click on the search, you can search anything here, anything. I can type in management group. So it shows me management group is what I'm looking for. So I click on management group, and you see what happens here is that it opens up the management group page here. It is going to show me what management groups do I have. Now, yesterday we talked about the fact that basically there is basically a root management group that I told you about yesterday, right? There is a root management group on the top, and that root management group is this. You see this tenant root group. This is my root management group. And then thereafter, the hierarchy goes like this, that I have management group within that subscription. Now, what you see here is that I have a root management group. I don't have any management group. Then I have a subscription, which is directly inside the root management group. And that's how exactly it works. So what happens is, if you don't have any management group created, right, root management group would be there. And any subscription that you create in that case, that subscription would directly roll up to the root management group, is how the structure is. Okay. Now, if I want to create new management group, I can do that. And I told you yesterday that if I have various business units, right, like sales, marketing, and IT, I can actually start creating management groups to manage that. So I can click on create button here, and I can provide the name of the management group. See, let's say IT management group, and then the display name of the management group. So I would say IT management group, right? Or let us just say IT, and I say submit. So what this does is that it basically creates a management group. And similarly, if I want to create more management groups, I can do that also. So I can say, let me just refresh this page. So click on refresh, and it will get refreshed. But you can see on the top, right, the progress. So that means that it is still creating the management group, and it is not yet completed. Okay. Once it is completed, it will appear here. And similarly, if I want to create another one, let's say, let me create another one, sales management group, and I call it sales, and I say submit. So just for the demonstration purposes, I have, I will have this management group created shortly. And once we have that, what we have done is that we have basically seen the management group. Now, inside the management group, I can then have a subscription, right? So right now, as you see, my subscription is directly rolling up to root management group, which would be the case. If you didn't create any custom management group, then any subscription that you have would roll up to the root management group. But now what I can do is imagine that this subscription that I have already has to go to IT. What I can do is that I can now click on the subscription and I can say move. So let us move this subscription into IT management group. So I choose out of the two management group, I choose IT management group and I save it. Now my subscription is moved into IT. Now, what does this moving of subscription means? It means that now within IT, I can have one subscription or I can have 10 subscriptions. I can govern them all from a single place, which is called IT management group. If I wanted to see spending across all the 10 subscriptions in IT, I can do the cost management, cost monitoring, etc. How much am I spending at the at the management group level, at the IT level itself. Okay. So now subscription is sitting here in this management group. And if I want to move this subscription around, I can move. But that will not be very likely scenario, because when you are creating all this, at that time itself, you will take a very thoughtful decision how many management groups should be there, right? And then where should your subscriptions be hosted? And once you have done that, you would not be moving the subscription from one place to the other. Now, if you wonder why should I not be moving my subscription from one place to other, why is it, let's say, so tricky, so difficult? It is difficult because management group as we create, IT, sales, marketing, these management groups, as you can imagine, might have different policies or compliance requirements. And all those policies and compliance requirements needs to be adhered to by every service that you provision in Azure, right? So for example, HR would consist of sensitive data, right? Now they might have additional stringent policies which are to be applied. So those stringent policies we can apply at the management group level. So once we apply that policy to the management group level, let's say to the HR management group, if you move a subscription from elsewhere to HR group, what happens is the policies are already there in the HR group, and that HR management group would enforce the policies to the subscription, right? So what type of policies would that be? We will talk about that, okay, in the fourth session. But remember, there are some rules, some governance policies that we define. One policy could be that, hey, any resource that we are creating that has to be provisioned in South India region. There should be nothing provisioned out of South India region. So we can create this as a policy, and then we can enforce, we can attach that policy to the management group. So HR management group now enforces everything to be provisioned only in South India. Okay. And if you move subscription from elsewhere to HR, then what happens? If you have resources which are not in South India, it will basically create a alert, right, saying that, hey, non-compliance, you have resources which are out of South India. Okay. The movement will not be very common is all I'm trying to say, but understand all this jargon as to why do we have even this concept of management group and then subscription in there, and why is it not very common to be moving the subscriptions around. Okay. So here we saw management group and then a subscription in there. Okay. Now let me click on the subscription, because next in the hierarchy is subscription, is what we saw. So once you look at subscription now, you click on subscription and see, you spend a little bit of time on the portal and you will get familiar with the portal. So not to worry about that. Now, you see in the subscription, there are so many things, right? I have a subscription ID, which is a unique ID that Azure will give you. Okay. I will pause. There is a question in the chat. Can subscription belong to more than one management group? Okay. No, it cannot. So you are anticipating different situations, which is good. But to set the record straight, that cannot happen. One subscription belongs to only one management group because it is physically placed inside that. Okay. And if a subscription is not in any management group, then it will roll up to root management group. Okay. And all the management group that we are creating, IT, sales, marketing, HR, they all also roll up to root management group. So see that root management group is your parent, okay? And then within that, you basically have management groups, and then within that you have subscription. Is how you have to see that. Okay. So you have subscription ID, you have directory also, the directory which I was showing you earlier, right? And you have subscription name, current billing period. So you can see that billing is done normally on the monthly basis. This is what it is telling you. So in case they ask you in the exam saying that, hey, how is the billing done? The billing from the subscription perspective is done on the monthly basis. Okay. There are cases where Bella, in our case, can agree with Microsoft that I want to pay for whatever resources I'm running on an annual basis. I will pay you upfront in advance for the whole year. In that case, Microsoft can give you further discount, but we will talk about all of that later. But usually the billing is done on the monthly basis. Remember that. Now, if I go to cost management here, if I go to cost management and cost analysis, because I told you earlier that we are using subscription to, as an boundary when it comes to the cost management, right? Or as a billing boundary. So it will basically tell you how much have you spent in this subscription. And as I create resources, I spend, of course, I spend. So I have spent 22.81 so far. My forecast is that until the end of the month, I would be spending 40.80, right? This is the subscription that I've chosen. As you can see, I have only one subscription, so it doesn't matter. But you can see this is the scope. See that this is the scope, okay? It is also choosing the period, the month. It is also showing the forecast. If I scroll down, I can see where have I spent it all. I might have spent it at many different places. It will show me all the services. See, storage, I spent about $20. Virtual network, I spent about $3.50, right? And then in which location, in which region did I spend how much? It will show you that also. And resource group name, it will tell you the resource group name also. We'll get to that. But this is all what you can do with subscription, is where you come to do all the cost management and all those things. Okay. That is next thing. So we have looked at subscription. Now within subscription, you then create resource group. Now let's take a look at resource group. We come back to the portal and I'll go back to the home page. I can either do that. I see resource group here, or I can just come here on the search and I can say resource groups. So this will come up. I click on resource group, and what it will do is it will show me all the resource groups that I have here, as you can see. Now I click on create a resource group. If I have to create one, I can create one. So see, the moment you go and create a resource group, it is asking you for a subscription. So you must provide a subscription first. And I'm choosing my subscription. I only have one. You might have more than one also. I choose that and I name it, let's say resource group IT. Okay, resource group IT development. And then region. Now see, yesterday we talked about region. Now here you can see that there are so many regions available. What I will do is I will choose Asia Pacific. So remember that we spoke about that in the last class, right? Geographies, 4 geographies, and then you have region, Southeast Asia being one, and then within that you have data center. But when you provision the resource, you don't have ability to select a data center as to which data center does it go to. No, you don't have that. So I will just choose Southeast Asia, and then I will go to next tag. I will leave it for now, review and create, and then finally I will click on create. So thereby I just created a resource group. As simple as that. Okay. Now I have a resource group created. After that, I can have resources. Within the resource group, I will then have resources. So if I click on resource group, my resource group is right now empty. So I will come back later and I will create a resource here. And the first resource that you're going to create would be a virtual machine, right? So maybe let us just do that now. So now I'm creating a virtual machine type of a resource. Okay. If anybody is not clear what a virtual machine is, type it in the chat window. So I will create a virtual machine. Now, to create a virtual machine, there are two ways. You directly click on create while you are on the resource group, or feel free to navigate around the portal, right? Just go to the top and type in virtual machine. Okay. And we go to machines. And there is no virtual machine right now. I can create one. So I click on create, or I can click on create here. Azure virtual machine. Let's choose that option. And once you have done that, it will open up the page. So I will very quickly run through this process. Again, observe few things, not everything, but few things here. Again, it is asking for a subscription and asking for a resource group. Do I want to create a new resource group? No. Select the existing resource group that I created. I will choose that. Okay. Then virtual machine name. Let me give it any name. Let's say uh, VM test 01 is the name of my virtual machine, right? Or let's say VM web 01, just to indicate that it is a web server, right? So things like that. VM web Southeast Asia is a region that I'm choosing. And now notice this. Now say this is important. Now here is where the things that we covered in the last class would start to make sense. Availability options. We spoke about different availability options. What availability options do we have? I can choose no infrastructure redundancy, which means only one instance of VM, no redundancy, no duplication across data center or across rack would happen. Okay. If I choose availability set, you know what does that do? It can withstand the hardware failure using update domain and fault domain. And for those who did not attend the previous session, attend that and then watch this again, and it will make sense. Availability set, or you can choose availability zone, which gives you 99.99% of availability. We are not going to virtual machine skill set at this moment, but let us choose availability zone. And then you can see in the availability zone, it is showing me 3 zones. So we spoke about that, right? That you have 3 zones available. In one region, you have 3 availability zones. Also keep in mind, there are many, many regions when it comes to Azure. Not all the regions might support availability zones. There could be some regions where you cannot use availability zones at all. And there, customer have no option but to choose availability set, let's say. Okay. But wherever you have, whichever region that you have availability zones, you can use that. Now, if I choose one zone, it will create instance of that virtual machine in only one availability zone. If I choose 2, it will create 2 virtual machines, one instance in one zone, another instance in another zone. So remember that. Okay. For now, just to be efficient, I will just choose one, and don't look at each and every option. Okay. I will just choose whatever is default. I am creating a Windows machine, and username and password, of course, right? This is something that I will have to provide. So I will just provide a username and a password here. Okay. Now, see, this virtual machine is being created where? In Azure, right? And we have to connect to that virtual machine over the internet, right? To connect to the virtual machine, it has to open up a particular port, right? We have to use the port. Let's say I'm trying to do a remote desktop. Now the default port for remote desktop is 3389. It is asking me that although you are creating a virtual machine in Azure, do you want to open up RDP port or not, right? So how does it work is that, this is Azure. Now see, this is Azure, and you are basically creating a virtual machine here, right? You are creating a virtual machine here. So this is your VM, and you are basically somewhere here, and you are actually connecting to that virtual machine over the internet. Now to connect to that, we need to open the port, and that port is this 3389. Okay, so I must open this 3389 port for the VM so that anybody from outside can connect to that. In From the security perspective, I might not allow that, right? That I don't want to open the port at all. Imagine that Bella is running her production system, or a bank is running their production machines. They won't open RDP port at all, because the moment you open, you allow somebody to come to the machine. And if that person also knows the user ID and password and the port is opened, they can they can log into the machine and they can do whatever they want, right? So breaking through the password is not a big deal. So you actually secure your virtual machine by not allowing RDP at all. And that's how we have to do. If you don't open the port at all, there is no question that Anybody can connect to that from outside, from the internet. Okay. So now what I would say, don't open. Security first. Okay. I want to keep it secure first. Don't open any RDP. Okay, fine. We go to the next. It'll ask me, for the disk. It'll ask me for the networking, etc. I'll just click on next, next for now. Okay. I'll just click on next and next. And monitoring, advanced, tag. Okay. And finally, I would say, see, there are a lot more configurations when it comes to creating VM, but we don't have to worry about all of them for now. Okay, validation is passed, and I'll just click on create. Right. Now, while the virtual machine is being created, it'll take like a minute or so. Let us now try and understand what is happening here. Okay. Now, what is happening here is that Azure is trying to create a virtual machine, which is a resource. Okay. As you can imagine, when we have virtual machines, etc., deployed in our on-premises data center, one basic component that we require is some networking, right? These machines have to be on the network, right? How Azure manages that is that in on-premises, we have our own on-premises network. From Azure perspective, although it might sound new to you if you're fresher and if you don't have any experience in that area, but just remember that, right? In Azure, we actually have something which is called as a private network, and we call it a virtual network. The network in Azure is called as virtual network. Virtual because it is virtual, right? It is a software-based network that Azure is helping to implement. There is nothing physical in here. Now, you need to have a virtual network to create a virtual machine. So that means that when I created my virtual machine, it would automatically create a virtual network because that machine has to sit somewhere in a network. And see, if you come back here, if let's say I opened up 3389 RDP port here, right? If I had opened that port, how do I identify that virtual machine? Everything has to have an IP address, right? This virtual machine would be having an IP address. And that IP address has to be like a public IP address, which can be seen from outside. Okay. So that public IP address has to be there. And that public IP address is how the machine will get identified. Correct. Now, we have virtual network. And then what happens is within that virtual network, I then basically further segregate based on something called as, so this blue box is virtual network and this black box is actually what is called as subnetwork. So look at it this way, that you would have a virtual network created, and within virtual network you would then have some subnetworks created. We do this segmentation within a virtual network, which is a private network. Why we do that segmentation? Now, let me take you back to the example where we started in the first class, right? We were talking about Bella's business. And we were saying that Bella would be running a website. We also talked about a little bit about three-tiered architecture, right? Three-tiered architecture, wherein we were saying that, first layer would be the web layer, where all the web servers, where requests from the internet, from the outside world can come in. Those servers are connected to the internet, right? Then we were talking about app layer, where business logic, that discount calculation, how many items is somebody buying, etc., would come in, right? And then basically the database, where all the data, invoices, inventory, transactions, and all that would be captured. So in a way, we require three layer, and that is what exactly this diagram on the right is depicting. Subnetwork, I can segment these different types of servers using subnetwork inside a virtual network. Okay. So remember the definition. Virtual network is a private network in Azure. Okay. You need a private network. And then within private network, if you have different types of workload, different nature of machines that you are deploying, for that we create subnetwork. Now, by creating subnetwork, what I'm doing now is that I am basically, then deploying virtual machines in this manner. Okay. If there are two web servers, I deploy two web servers in one subnetwork. Okay. Similarly, I might have two application virtual machines in app layer, right? And here I might then have basically two databases also, two database machines also. So I separated. Why, why did I do that? Anybody? Can anybody do a guess? Why do we have to separate in such a manner? Why do we have to segment that? Type it in the chat window. In the meantime, I will go back to the portal and see whether VM is created or not. Yeah, so VM is created. We can go to the resource. Anybody? Any guess? Why are we even doing this segmentation? Anyone? Put it in the chat window. No? Nobody? Okay, or perhaps independent functioning. Yes, independent functioning is one thing. We want them to function independently. We want them to function independently because multitasking, not quite. Can you replay what did you segment? Okay, fine. Let's come back here. So I segmented web servers into one subnetwork, application servers into another, and database servers into another to handle different types of requests. Okay, for the port and RDP. Okay, right. Okay, so see, I would say that you are getting there. You are getting there, but let me explain that to you. See, if you think about a web server, it is actually the first place where a request from the internet would come in. Correct. Now, when the request from the internet would come in, you will have to open up this server so that a request from internet can be taken, can be accepted. Correct. So you will have to basically, open up. Let's say if somebody's typing in www.bellaboutique.com, that website is hosted on these web servers. So that request has to flow inside and it has to come in here, right? Hit the web server. So these web servers, we can say they are basically internet facing. Okay, let's call that these web servers, they have to be internet facing, that they should be able to get a request from the outside. Do my application servers need to be open to internet directly? No, because only place where the request would be received openly are web servers. Then web servers, let's say web server received a request from the internet, right? Let's say HTTP request, okay, which basically goes over port 80 or port 443. That request comes in. Then web server should be the one that should forward that request to the application server. Can a user like me who is accessing the website be able to forward that? No. It is only the web server's job, right? So in a way, we can clearly see app servers need not have similar level of network security that web servers have. Web servers can be a little more open, right? Application servers can't be. They have to be blocked. The only way to access app server is via web server and not directly from the internet, right? On the other side, similarly, once request is sent to application server, then application server will go back to the database. Now, database is sitting at the bottom, right? Again, the same logic. And if you think about it, it is okay for the web server to call up app server. It is okay for app server to call up database server, and then request would be served, and then it can be basically sent back in this manner, right? So this is basically the loop, right? So this is how the loop is, you, as you can see. Now, tell me this: should we ever allow web server to bypass application server and go directly to the database? If yes, why? If not, why not? Take a moment, think about that, and put it in the chat window. No. Yeah, answer is no, right? No, we should not allow because requests from the internet are coming in directly to the web, right? So, and we only allow application business logic to only get the data that is required by the business logic and not directly. Okay, data security and data integrity. Yes, yes, absolutely, absolutely, right? So, uh, uh, yeah, we'll get to the load balancing, Jagtar. We'll get to that. So there is no there is no way that we would ever allow something like this. That request comes from here and it goes directly here. No, we will never allow that, right? But how do we prevent? We basically prevent it. We actually prevent it by creating network rules. We create network rules. I create rules in such a way that okay, any request originating from the web server can be accepted by application server. Okay, or in other words, application server can only accept a request when it is originated from the web server. The originator has to be web server, right? And then application server would only take requests from the web server. It cannot take from database server, right? It cannot be the other way around. The originator has to be web. So what I would do to define those rules is actually another thing that we have in Azure. What we do is, because the nature of the servers are different, right? In Azure, we basically create something called as these purple boxes. They are called as network security groups, or in short, we call them NSGs. Okay, important concept. So, network security groups. What is network security groups? They are nothing but they let you define what? Rules. Exactly, the rules of engagement, right? Who can take what request? Inbound request, outbound request, right? What is allowed to come inside inbound? What is allowed to go outside from a place which is outbound? So NSG defines rules which actually lets you determine what inbound and outbound traffic would be dealt with or how it will be dealt with, right? Now, inbound is when the request is coming into web server, which is here, right? You would say that, okay, on a certain port, not on RDP. Somebody mentioned earlier that, that RDP would come in. M mentioned RDP will be kept open. No. See, you have to look at it from the end user perspective. An end user perspective is the user like me who is typing in bellaboutique.com. I have nothing to do with RDP. I am not going to RDP to the server. So that is out of question. For me, it is only that I should be able to enter the website name, and then website would be website name. That website is hosted on the web server. It should be able to go to the web server, and that's an HTTP request, right, over the internet, and that is over port 80, 80 or 443. So if it is, let's say, only HTTP request, then it is 80. If it is HTTPS, like a secured request, then it is 443, right? Like when we make payment, etc., we see that it has to be always HTTPS. So that's the difference, right? That one is secured, encrypted, HTTP, if it is HTTP, not encrypted. So what I'm saying is inbound rule should open port 80 or 443. Only then web server can take the request. So this NSG that I'm defining for the subnetwork, which is hosting the web servers, would have a rule, inbound rule, that would open, that should allow port 80 or 443. If it doesn't allow, the request cannot come in. That is just one example. Okay. Similarly, at every segmentation level, at every subnetwork level, you can have those inbound and outbound rules defined, and that is exactly what network security group allows you to do. Remember the definition. You hear it again, you will remember it. You will understand it. Don't have to go too deep into the technicalities of that. Okay. So simply NSG creates rules inbound, outbound. Remember this, that we attach network security group. We can attach network security group to the entire subnetwork. As you can see, I am basically attaching it here to subnetwork because every subnetwork is hosting different types of traffic, correct? Sorry, different type of servers. So inbound, outbound rules would be different. Okay. Only one thing I think from the exam perspective that you have to remember is that when you create these inbound outbound rules, or maybe let us take a pause here. Let us take a pause here. Let me show you in the portal, the practical. We pause here, we go back to the virtual machine now, okay? And that virtual machine has been created. So let us go back here. Here is my virtual machine, okay? See, I hope it is not too small. If it is, I'll, just try and make it. Oh no, I shouldn't have done that. Okay, I hope you can see that. Yeah, let's just move on with that. So see, this is the name of my virtual machine. In which resource group? What is the operating system of that? You could have Linux, you could have Windows, it doesn't really matter, right? Location, Southeast Asia, which is in Singapore. Only one zone. Which subscription? I have all of that. And see, I also have a public IP address, as you can see. Because without public address, you cannot access this machine. So web server, if you can think, they must have public IP address. Because if they don't have, how would the request over the internet come in? It cannot come in, right? So web server should have public IP address. But application server are not required to have public IP address. Database server, not required. They can just have private IP address. So you can have two types of IP addresses, public and private. Public is open to the internet, private only internally inside the virtual network. Okay, right. So here is my virtual machine, and let me just try to connect to the virtual machine first. Okay, I want to connect to the virtual machine. I click on connect, connect, and it will, it'll ask me to download the RDP file. Fine, I can download this RDP file. And once I have that, let me just open this RDP file and I try to connect. Connect. So it is connecting to that IP address, and it is trying to see whether whether we can connect or not. So it is trying to do that. So it is trying to find that IP address, whether it can reach that virtual machine or not over port 3389. Did I open the port earlier while creating the VM? If you recall, put it in the chat window. Did I open the port earlier? Anupam is saying business logic doesn't get disturbed. Yeah, so business logic is not open to anybody, right? It's basically internal. Pradeep is saying database should only be exposed to app or web servers. No, database should only be exposed to the app server. Only app servers can connect to the database, can send a request to the database. Web cannot directly connect to the database. Okay. Uh, yeah, security purpose. Of course, we do that for the security purpose. Uh, and then web service is used to get input and send output. Yeah, application server is where core code executes, which will access database. Correct. Absolutely. So I did not open 3389. And since I did not open, I can't connect. I can't connect, right? But if I had opened RDP, where would have that rule gone? Where would that rule have gone? Where would that rule? Where would have that rule got created? That rule would have got created in network security group. Let's go to network security group. Okay. See, I've created only one machine, right? Imagine that I've created only one machine, and there is one web server. So what I've created is perhaps only this piece. And this I'm talking about basically, opening RDP port, which is 3389. So fine, perhaps I have an administrator, and that administrator need to log into the machine to do something. It is not for the end user. If it is for end user, whether my website can access it or not, then it would have to be port 80 or 443. So keep that very clear in your mind. Okay, we are talking about RDP, which is perhaps for an internal administrator. So let's go back because I was not able to RDP. It gave me an error, right? Let's come back here. On the virtual machine, see, you have to spend some time exploring. There are many options, but I will, if you think logically, every virtual machine would have some networking component. So on the left hand side, you have various options, right? Connect, networking, setting, availability, security. I go to networking, network setting. Okay. And when I go to network setting, I will see, if you see network interface, load balancer, virtual network, subnetwork, see, it is showing your virtual network. It is showing you the name of the virtual network is VMweb 01 VNet. It created automatically because without that virtual machine cannot be created. You first need to have virtual network, then you also need to have a subnetwork. In this case, I did not give a name like web subnetwork or app subnetwork or DB subnetwork. So it created one with the name default, and that's fine. That's fine, right? So public IP address, private IP address. Now you see here network security group, and that's what we are looking at. And if I click on this, you will be able to see that it gives me inbound and outbound rules as you find here, right? If I click on inbound, it shows me there are three rules already defined. They are system created rules. I don't have to do anything. I don't have to touch them also. But what I can certainly do is that because I don't see RDP allowed here, you see, I don't see any RDP allowed. So you have the rule and then you allow or deny, right? So you basically, when you create a rule, you say, if I click on add here, so don't worry, it will take you some time, to get familiar with all this. You have the video recording available. Go through that a couple of times. It will all be very, very clear. It is just that there are too much of things, but as long as your mind is clear, you will be able to spot what we are talking about. Okay. So I'm saying from web server perspective, any source, allow traffic to come in from any source, any port. I don't care, right? Why would I care what is the port of my machine? I'm just sitting here and typing in bellaboutique.com, right? So any port is fine. Destination, I would say any. Okay. Custom, which what do you want to allow? So if you come here, you should actually be able to see remote desktop also. So RDP for Windows machine, and we usually have SSH for Linux machine, right? I would say RDP. So it is automatically taking 3389, right? And now what is the action? What do I want to do? Allow. I want to allow, right? So allow, and then priority. See, notice this priority. You have to have the priority for every rule. If you have one rule with priority 100, you have another rule with priority 200. Okay. First rule allows 3389, which has priority 100, allows 3389. You have another rule with priority 200, which denies RDP. Okay. Which one would take effect? What do you think? The one with the priority 100 or 200? 100 allows, 200 denies. Which one? In this case, remember, the lower the priority, uh, the lower the value, higher the priority. The lower the value, higher the priority. Okay. And it's basically a simple filtering rule that network security group has. It basically starts from 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whichever priority comes first, okay, 100 it finds, because it is looking for RDP. It finds RDP allowed or not. It goes through from 100 it finds allowed. It will not even go to 101. No, it will stop there because it found 100 priority RDP allowed. Even if you had 101 where you are denying RDP, it wouldn't go there. The first rule it takes, whether it is allowed or denied, it would do that. Okay, remember that. So priority is important. And I add. So now it is creating a security rule inside network security group, and which is an inbound rule because I'm an inbound, right? So it has basically created that. Now, since it has, see, it is giving you a warning that, hey, please don't allow RDP because it poses security risk, right? But I am taking a decision myself that, okay, I need to, fine. Now, if I come back here and, I try to log into the machine, I would have downloaded that file somewhere here. So let me now, click on the file that I just downloaded, right? See, this was the file, right? This was the file, VMweb 01. So I double click on that and it would basically open that RDP thing again for me. And this time, oops, sorry. Yeah. And this time it is asking me to enter password. Now that means that rule has worked, right? Now everything is fine. Yeah, lesser means higher priority. Correct. Yes, Sam. Uh, yeah, so as long as you understood, that's fine. Okay. So I can now log into the machine, as you can see, right? I'm logged in. Here is my virtual machine. Let me just minimize that. So here is my virtual machine. And we created a virtual machine. We used a virtual network. It created a virtual network. It created a subnetwork inside that, which was for this one. It deployed a VM in there. It created a network security group automatically, and it was associated to this subnetwork. And as you expand this, you would be creating another subnetwork for app, another subnetwork for DB, perhaps. You can have two more network security groups created. You will define the rules accordingly. Okay, you will do all of that. So, what have we covered? Virtual machine. How do you provision or create a virtual machine? It is a very straightforward process, as you saw. To do that, we need virtual network, which is a networking service. Okay, I could have gone ahead and created virtual network first. I could have then gone ahead and created subnetwork in that virtual network first, right? So I could have gone step by step if I know all of it. But for you, as we created the virtual machine, Azure makes it easy for you by automatically creating it for you. Okay. So, but it did that. It did all of that. So virtual machine required virtual network. It created subnetwork. It created, and then it placed a virtual machine in there. It associated a it associated a public IP address with the machine and also private. All the virtual machines will have private IP address, but web servers need to have public IP address also, as you can imagine. It also created network security group, inbound, outbound rules. You saw that. How does the priority work? You saw that. Okay. And we had our virtual machines working and functioning fine. Any questions? I will pause here. I will give you a moment to digest all of it. And in the meantime, I will just come out of the virtual machine. I don't need that anymore. Any questions, put it in the chat window. And this is your time to do that. Any questions? All good? Okay, fine. Now we will come back to a few more things. I created a virtual machine and Azure is charging me for that virtual machine, right? And for that charge, I already have a subscription created. Now from the subscription, it will deduct the money. For as long as virtual machine is running, I will pay. If I come back here to virtual machine, see if I leave my virtual machine open running, it will keep charging me. So what I do is that I come back here and I stop the virtual machine. Please stop. Now once I stop the virtual machine, I will not pay for any compute. Like I will not pay for CPU, memory, etc. I will not pay for that. But I'm still paying for the disk, C drive, D drive, right? If I had something stored there, Azure is giving me right certain amount of storage, right? Let's say 10 gigabyte, 100 gigabyte, 20, right, or maybe 200 gigabyte. I'm still paying for that, although my machine is stopped. So just the compute you are not paying, but storage you are still paying. If I don't need the virtual machine at all, then what I should do so that I don't even pay for the storage, I should actually not just stop, right? But I should look to delete the virtual machine altogether. So I can click on delete so that I don't pay for anything because I'm not using. So it doesn't really matter. So resource to be deleted, yeah, basically help me delete the virtual machine and delete the disk also. Let's say apply force delete. So delete everything, right? I'm saying that delete everything. Everything should be deleted. So I don't pay for anything. So this should now be clear to you as to what we are doing and why we are doing that, to save some money. So you have to manage the resources diligently. Later on, when you practice, right, you get the free subscription. Follow the same practice. Switch off. If you're not using, switch off at least. Or if you're not using it at all, then deallocate, delete the virtual machine so you don't pay. Okay, is your VM login connected only to one subnetwork? See, VM login is for virtual machine. That is for virtual machines. That is like a user ID password, in the same manner as you have for your laptop. Every VM can have different user ID password. It has nothing to do with the sub network. Okay. So login is for every virtual machine. Every virtual machine can have different user ID and different password and all that. Okay. Right. So we spoke about we spoke about virtual machine, of course, and I hope you are now clear what virtual machine is. It is basically a type of a compute resource that we have. It is a type of a compute resource. So if I were to talk about different types of resources, you can now see that I basically have some compute resources. Okay, and one of the example there is, of course, virtual machine. Virtual machine is one example of that, right? There are a few other examples of compute services. If we were to move forward, we will look at that. But in addition to that, I also saw some of the network related services, right? For example, virtual network. We saw sub network. We also saw network security group, right? We also saw IP addresses, be it private or public. We saw all of that. Those are all networking related services, right? Now, coming back to the compute services, we have few more services which basically come in the category of compute. Let's talk about them a little bit now. We have a service which is called app service, right? Or Azure app service. What I will do is, for better explanation, and of course, you would have access to the whiteboard and recording. Right. So these are basically some of the compute services, and I'll put a screenshot here. No, I think it didn't take that. Let me just get that again. Yeah. So the key compute services are these. So virtual machine, we basically spoke about, right? Virtual machine, we spoke about. So that should be okay. We have understood that. Now, in addition to that, very quickly talking about app service. This app service is a service in Azure. See, virtual machine was serving a purpose that get a virtual machine and put in anything that you want. App service is meant for the purposes where, remember IaaS and PaaS, right? We spoke about IaaS, infrastructure as service, and VM is a classic example of infrastructure as service. If I wanted to deploy Bella's website in a PaaS type of a service where I don't have to manage operating system and all that, app service is the answer. So app service is actually a PaaS service that lets you deploy web applications, right? Or mobile applications. but it's a PaaS service. So you bring in your code, your website, and you deploy it here. You don't have to manage any virtual machine. Is what app service basically allows you to do. Okay. Now, uh, then we have container instance. Now, this container instance is another PaaS service. Container instances, you might have heard about. Definitely, I'm sure you must have heard about Docker, right? You must have heard about Kubernetes, etc. So those are container platforms, right? Container platforms. Now, what happens is for a typical machine, right? For a typical machine, the way we work is, that I mean, if you have heard about the concept of virtualization, right? Things like VMware, if you have heard about that, then what it does is that it basically virtualizes your hardware, right? So you basically have a huge amount of, let's say, compute and storage and memory. And what this what these technologies like VMware or Hyper-V do is that there is basically a hypervisor sitting on top of that compute, and on top of that, it can then allow you to create multiple virtual machines on the same hardware, right? So imagine that you have one rack that has a lot of compute, storage, memory. With the help of virtualization like VMware, you are able to then create multiple virtual machines on top of that. And this is exactly the VM that we created just now. But still, every VM has operating system like our laptop, correct? Containers take it to the next level. What containers do is that they basically, virtualize the operating system itself. So you just need one machine, one VM that underneath has compute, storage, and memory, right? You just need one VM. And behind the scene, there could again be this entire thing where you have the common compute and common storage and common memory, etc., etc., etc. Right? You have hypervisor also. But within the same machine, you can actually create multiple containers. So what you're doing now is that rather than having one machine for one purpose, another machine for another purpose, let's say one machine for web server, another machine for app server, you can actually create containers. If you needed two web servers, you would create two VM. No, rather than that, you can actually create two containers. Both the containers are running on the same machine. And when you are able to virtualize the operating system itself in this manner, see, firstly, you don't have the overhead of running operating system on every machine. Otherwise, some memory will definitely be consumed by operating system, right? So that's why container become a very useful technology. They are very lightweight processes. They are isolated from each other. And you can then start deploying, let's say, your web server on one container. You can spin up another container. So you have two, and then the load can be distributed, right? You can do all of that. So those are the benefits that container bring, that they give you a lightweighted approach to deploy applications. And if you have heard about microservices, containers, it is all that. So container instance allows you to deploy container instances. So I could host entire Bella's website in one container instance. I could do that. Not the databases. Database would have another container. Application layer would have another container. Okay. Another service, another PaaS service is Azure Kubernetes service, right, or AKS in short. This is again a PaaS service. Now, what Kubernetes allows you to do is that you might have basically hundreds of containers, or in any enterprise setup, you might need a lot of containers, right? Kubernetes act as an orchestrator of all these containers. So it will help you manage security. In case one container fails, it will automatically get the fresh image. It will spin up the container. It will manage the networking aspect of that. Not going into too much of detail, look at this Kubernetes as an orchestrator of containers. So this is being offered as a PaaS service. Just go, as I deployed VM, you can deploy entire Kubernetes cluster, which would have multiple machines, right? In a few minutes, you can do that. Virtual desktop is basically virtualizing our laptop, right? So usually I get a laptop from office and I install 10 different things on that. With the help of virtual desktop, we don't have to do that. Our desktop is virtualized in Azure, right? I just need a machine where I need to RDP. I just RDP to that machine, and that's where I'm installing all the softwares, etc. So that is Azure Virtual Desktop. So rather than having a very big machine, a very powerful laptop, you have now basically uh, you basically now started to offload all that to the virtual desktop in Azure, and there you can have much more power and much more capacity. So you can have cheaper laptops on your side, of course, right? Because you just need to RDP. So that's what Azure Virtual Desktop allows you to do. Okay. So these are some of the compute services that we have. Networking services, of course, we basically spoke about that. So I wouldn't go into that. But there is certainly one more thing which I want to talk about, which is, and it's an important concept. So when we talk about virtual machine, there is this another associated uh, topic which is called virtual machine scale set, or we also call in short as VMSS. So what this VMSS does is that it basically lets you have a set of machines, right? It lets you have a set of machines. So to better understand that, we talk about web, right? You can actually do it in this manner, that if you needed to have multiple web servers depending on how many requests would come in, you can actually create a VMSS in which there would be multiple virtual machines created. So you would name this thing as a virtual machine skill set, right? You can give it any name, virtual machine skill set one. In that, you would then say, okay, what should be the minimum number of virtual machines it should have? What should be the maximum number of virtual machines that this virtual machine skill set should have? Okay. And then you define the condition. Let's say minimum is 2, maximum is 50. Then you can say, okay, start with 2, and if you find that CPU consumption is going above 60%, spin up 2 more. It would automatically spin up, and it would also automatically scale down. So that approach is flexible. Then, right? It is of course flexible because then you can use this power, right? This elasticity to to scale out or scale up on demand, scale out actually, and then scale back or scale down also. Okay, scale in also. So that is what virtual machine skill set allows you to do. So we typically use that when you see there are different web servers or a number of web servers required, the traffic basically fluctuates. You would reduce virtual machine skill set and let it manage. Okay, right. Now, we spoke about basically Azure App Service. We spoke about virtual network already, and yeah. So there are a couple of more things when it comes to networking. Let me just let me just cover that. So see, when it comes to networking, if you think about it, right? Yeah. So you see, we have on one side we have on-prem data center, right? On-prem. Let's say Bella is running a few things in on-prem at this moment, but she decided to take her website to the cloud. Okay. So this is basically the boundary. This is the boundary. This side is on-prem and this side is all cloud. Then we came to Azure, right? And in Azure, we basically started deploying applications and all that. Okay, we started doing all of that. At some point of time, there is this need, and see, it is already becoming what type of a cloud? It is already becoming hybrid type of a setup, right? It is becoming hybrid cloud type of a setup where Bella has few things running in on-prem and other things running in cloud, correct? So we now need some sort of a mechanism that can help us connect on-premises systems to what we have in Azure. How do we typically do? there are two options, right? There are two options. One is, you must have heard about VPN. I'm sure you must have heard about virtual private network, right? VPN. VPN basically is an encrypted connection between two sites. If it is site to site VPN, let's say on premises data center and Azure, but it goes over internet. It goes over internet, and internet could be slow, fast. Sometimes would send data very very quickly. Sometimes would take a lot of time. So not reliable. Correct. If you need reliability, right? Reliable data exchange, you cannot rely on VPN for that. And if, let's say, there are customers that require a lot of data to be sent out on a daily basis from on premises to cloud, right? Or the other way around, then VPN would not help. So what Azure allow you to do is something called as express route. As the name suggests, express route is basically a dedicated line. It actually creates a dedicated line from customer data center to the nearest Microsoft Azure data center. It is a dedicated line, okay, private line. Now, since it is private, direct line, FiberNet, it is very fast. So there are two ways to establish this connectivity. Understand that, okay? VPN over internet and express route, which is dedicated. Just remember this much. You don't have to go, so much more into details. But just note that be it VPN or express route, what I need is a gateway on both sides. Okay. Remember this much, that you would need a gateway. Okay. So I actually need one gateway here, and I need another gateway here. And through that gateway, I will connect. If it is VPN, it will be a VPN gateway. If it is express route, it will be an express route gateway. So I will create a gateway here in on-prem, another gateway here, and then I will create between them what is called as a connection. Is how it is done. Don't have to go into details, so much of detail as I mentioned. Okay, so don't worry about that. So this is how it would happen. So this is the mechanism by which you can connect multiple systems, multiple sites together. Okay, right. Uh, sorry, I see a question here. One second. Is Azure Virtual Desktop IaaS? Uh, that's a good question. That's a good question. It is basically a virtual machine, right? So that virtual machine is managed by Azure. So we would say that it is an IaaS, but we don't have all the responsibility to manage that in such a way that I don't have to manage network security group. I don't have to manage virtual network or subnetwork for that. I don't have to get into all those. Okay. So behind the scene, it is running as VM, but as long as I'm not responsible, it is fine. And since I'm not responsible, we will see it as a PaaS because I'm not managing it. Okay. Okay. So that's the answer to your question. All right. So this is another. These are a couple of other networking services, and then one more thing, perhaps the last one that I would cover is DNS. I'm sure you must have heard about DNS, right? Domain name systems. So domain name systems are no, actually, Pradeep is right, right? It is also seen as a SaaS service when it comes to virtual desktop, because everything is given. You are only managing the data. So I would agree to that. Thanks, Pradeep. DNS, domain name system, is again a service. It basically lets you resolve, right? You have IP address, you have a website. How to map the two, right? That somebody would type in bellaboutique.com. How would it resolve, right, that particular domain name to the IP address within Azure? For that, we have basically, Azure DNS service that can help you do that. Okay, so that is on the DNS part. Okay, so yeah, these are the networking and compute services that we had to talk about. Today, we will focus on these two, number three and number four. Okay. So that is where I'm going to start this session. Now, let me go back and I am going to come back here. So whiteboard will be shared with you earlier, right? So don't worry about that. But today, what I want to cover is in this fourth session, I want to get started with the storage technologies. Okay. So we'll focus on storage technology. And one good thing is that, earlier in this particular course, there used to be a number of services that we used to cover. I remember my time working at Microsoft, and of course, I was a trainer. If we had to deliver this course, let's say at the customer side, there would be at least 25 services that we will be talking about. Right? There were almost all the key services that we had to talk about, and we couldn't spend more than a few minutes on each service. So now the way the course is structured is actually much better because they don't focus too much on covering lot many services, but they have basically narrowed down the scope, and whatever they're talking about, uh, they're talking about it a little bit more, I would say. Okay, so that is a good thing. Now storage. Let's go to the storage, and we basically first dig deeper into that. And after storage, of course, we will get into another important area when it comes to cloud, right? Very, very important. You must have heard about security, cyber security, and those kind of things. So not going into cyber security, but we'll talk about the basics of security in cloud. I mean, as much as you are required to know. Let's get started. Storage. See, firstly, why do we need storage? I mean, today everything requires storage. Can you imagine any application that doesn't have some kind of storage behind it? Think about WhatsApp, right? Your data is being stored somewhere on the server. Any mobile application that you interact with, your data is being stored somewhere, right? Any banking application or any other thing, right? It actually requires some kind of a storage. So we can say that data is the core of everything because behind the scene you have data, some technology that is storing the data, right? Now, broadly, we can say that when it comes to the storage, there can be different types of storages. Just to very quickly give you an idea, we can basically have, uh, you know, we can actually have structured. We can have storage that stores structured data on one side, right? We have storages that store semi-structured data. Now, this is not necessarily covered as part of Azure Fundamental, but just setting up the ground so you understand where exactly the next service that we are going to talk about falling falling under. Okay, so structured, semi-structured, and of course, then we have unstructured type of data. So these are basically type of data types. Now, to store different types of data, we need different types of services. That is the reality. Okay. So service that we're going to talk about today is not focusing so much on let's say structured data. No, it doesn't. So it isn't focusing so much on structured data. It would partly focus on semi-structured, but it is mostly basically unstructured type of data. Now think about this, that you basically have a PC, right? You have a PC. This is your PC, and on the PC you are basically storing different types of files, right? Let's say you have C drive, you have D drive, etc. You have E drive, etc. And in this D drive, you are basically storing whatever you want. You're storing basically images, right? You are storing videos. You are storing CSV. You're storing document file, right? Uh, basically MP4, audio, video, whatever you're storing over there. All these are type of unstructured data. But we can also say that nobody stops me from storing a CSV file in there, correct? Comma separated file. Comma separated file. An example of comma separated could be 1, 2, 3, 4. This is comma separated file. Normally, when we talk about data management, right, you would hear that we read data from an application, store it in a CSV file, comma separated file. Values are separated by comma. Let's say ID, name, age, etc. Now, this can also be stored in your D drive, here. So we can say that, hey, this is structured because it has a fixed type of format, how many values, etc. But what we are saying is that you are storing it in a storage which is unstructured type. Okay, and this unstructured type of storage is also commonly known as, in the cloud term, it is also commonly known as blob storage. Blob stands for binary large object. Okay, blob, and you would hear about this term. Now, blob storage is used for unstructured data. Keep that in mind. Is what we are going to focus on. But coming back to the structured part a little bit, in structured part, we basically get things like relational databases. So database management system, relational databases, right, and data warehouses, etc. So if you have heard about SQL Server, that's basically structured data, storing structured data. If you have heard about Oracle, there is also structured data stored. And we normally basically store data in the tabular format in there. So it has a fixed schema. Semi-structured, are basically things like JSON or XML. Things like these are semi-structured, which has some structure but not entirely structured. Okay. Now, there are different services in Azure. There are some services that allow you to manage structured data. There are other services for semi-structured data, right, which is also called as NoSQL popularly, or document databases. And then you have storages for unstructured data. So what you're going to focus on is actually unstructured data storage here. Okay, unstructured data. And what is the service that you're going to focus on here? The name of the service that you're going to focus on is Azure Storage. Azure Storage. So Azure Storage is basically a blob type of a storage, binary large object. You bring in anything and you dump it here. There is no problem. It will take it. Okay, it will take it. It will let you store. And why this type of service is very common across all the cloud providers, right? In AWS, you would come across S3. In GCP, you would come across cloud storage. In Azure, we have Azure Storage. So these are very popular because they provide you a huge amount of storage, general purpose storage, which can allow you to bring any amount of data, any type of data, and dump it here in cloud, right? In the previous class, we were saying that some application might be running on-prem and other set of applications in cloud. Now, when you try to bring data from on-prem to cloud, you can use this type of storage as your, as your, how to say, uh, as your, what is the keyword for that? As your staging, right? So this is on-prem, get all the data and put it in this blob here on the cloud. And of course, this is Azure, right? So you put everything here in the cloud, and then from cloud, you take it wherever you want to take it. It serves that purpose. So this is what we're going to talk about. Azure Storage is the name of the service. Okay, so it is basically storage offered as a service. So we can also say it's basically a PaaS service. Okay, PaaS service, uh, or you can actually even call it SaaS service, right? Because it's basically uh, uh, I would say there is very minimal type of management that you're having to do. Okay, maybe let's keep it simple, right? Let's keep it simple. You understand this as a PaaS service. So basically, storage is being offered as platform to you. You have some control over the configuration and the management of that service, security, encryption, and all that. All that you would be able to do, but you can provision it with very minimal effort. Okay, so let's keep it to PaaS. Now, what you do is that you actually create in Azure to work with this type of service. You basically create in Azure what is called as a storage account. Storage account. So when you go to Azure portal, it will be asking you to create create a storage account basically, and you enter the name of the storage account, various other configuration, and it gives you an instance of that storage account. Okay, so that instance basically comes in, and then what happens is you start to upload data in there. I will very quickly go to the portal and I will show you how does it work, so you actually get to see as to how does it look in the portal. So let me just launch the portal, and I'm going to bring it here on this screen, and then we go into a little bit more detail about this service. Okay. Yeah. So see again back to the Azure portal, and if you type in storage account, so you will see the storage account here, and that's exactly what we're talking about, right? It provides you blob type of a storage. I already have one account available here, but let me just click on create, and I will start to create one account here. So we will not go into the configuration so much at this stage, okay? But let us just experience the process. So I select the resource group. I need a resource group to put this storage account into, right? So we learned that there has to be a resource group before you create any resource, and every resource goes into one resource group only. Then you provide the name of the storage account. Now let's say, going back to the same example, right? Bella's boutique. Now what Bella is trying to do is that there has to be a storage account where all the images of all the handmade jewelry that are coming in, she wants to put all those images in this blob type of a storage. Okay. So we say that Bella's boutique images is the name of the storage account. Okay. Now this account name has to be globally unique. It has to be globally unique. Okay. Why globally unique? Because this storage account is available over the internet. So you cannot have two storage accounts having the same name, because what happens is whatever name that you provide, there would be a URL suffix that get added after the name that you provide. And if two storage accounts have the same name, the URL would end up to be the same, and that is not allowed. So it has to be globally unique. And if it is not, it will tell you. It will tell you. Okay? I choose the region. I don't look at any other property at all for now. Okay. I will choose whatever there is, and I'll just move on to the next. Okay. And then, uh, fine. I will keep everything as it is. Next, 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 next. And then finally, I would say create, create. It will just take a moment for this to create the storage account. So we first see, right, as to once storage account is created, what can you do with that, for example. So let us get to see that. Yeah, it should be done in a few seconds. In the meantime, any questions, put it in the chat window. Okay. Mr. T is asking what is the minimum laptop specifications is required for the cloud engineer career. Okay, I'm sure you are looking to buy that since you are so determined to get into the IT. I can share my perspective in the group, right? So no problem. We'll come back to that. Just post it in the group. So now see, storage account has been created. Okay. There are so many other things that I can do with the storage account, as you can see here, right? There are so many things that I can do. Uh, but what I would like to do is that, once you have the storage available, right? So I have the storage account created. I would like to put some data. I would like to store some data in here, right? So what I can do is I can click on, see, there is a storage browser available here. I can go to storage browser. It would give me different types of storages that are available. And you see one type of storage is blob, right? Blob container. And there are different types of storages, few more types of storages. We will talk about that. But let me just come back here, and I would click on open in Explorer. So let me just click in there. Okay, fine. No problem. I think for now we will work just here. See what happens is you have basically a tool that allows you to interact with, so that storage becomes accessible just like how you access normal file system in your operating system. That is what this storage explorer is. But if you don't have it installed on your machine, it's fine. You can just leave it. So I will just go to storage browser, and in the storage browser, I see there is blob container. There are four types of storages that you see, right? Blob, file, tables, and queue. I will go to blob container, and I will just uh, basically add a container. So you first add a container. I would say uh, jewelry, jewelry, ancillary images. Okay, and anonymous access level, basically private, right? Don't allow anybody to access from outside. So I create that container, and once container is available, then I can go to the container and I can start uploading the images. So see, now once I come here, it is asking me to browse any file right from my laptop. Now let's say I choose any file. I choose this file from here, right? MongoDB, and I upload it. So normally how you work in operating system, you have a folder, you create a folder if need be, and then you take a file and you put it in there, right? Is what I'm trying to do. Just that in storage account, you create what is called as container, blob container. Why do we create container? Because Bella might say, hey, all the images, handmade jewelry images go to one container, right? There are other images which are not handmade jewelry, but she's extending the business, right? Let's say they are related to basically the handloom type of a work. So for that, she can have another container also. And some containers can be only internally accessible. Some containers can be made public, right? So she can share with outside world also. Anyways, so now we have basically this image that is available here. And if I click on this image, you see this image has given me a URL. And if I take this URL and I come here and I paste this URL here, right, you would see that public access is not permitted on the storage account because storage account is safe, right? You put anything in there. Bella is putting her business data. We cannot have the storage account being accessible to everybody, right? There can be another situation where she would like to make some data available to her other business partners, right? In that case, you might have to configure a little bit of security with respect to the storage account, right? Let us just see that for a moment. Uh, so I go to configuration because currently I'm not allowing storage account to allow any type of access. Okay, so see, allow blob anonymous access. This is basically one configuration just to give you a sense of security, right, as to how secure the service is. So allow blob anonymous access is what I am enabling here, and that's all. Let me just save it. So what I did just now is that I have a storage account. It doesn't allow public access to the data. And by updating this property in the storage account as an administrator, let's say, or as a data engineer, I just change that configuration so that it can allow access to that. Okay. Now, once I have done that, I will come back to storage browser and go to blob container again. And you see this container jewelry images, its access level is private, right? Its access level is private because when I created, I said it has to be private. Now, what I can do is I can add another container, let's say public images, and I do that. It's like, I might have to see it is saying that you cannot change this option, but it has to be private because access level is set to private because anonymous access is disabled. Although I have enabled that, but the page perhaps has not refreshed. So what I will do is I will just refresh the page so it can take that. I'm just trying to show you can change the properties. You can enable public access. Once you enable public access, to you upload any document in there like an image, I can take the URL. I can share the URL with you here in the chat window. Once you click on that, you will be able to access that file also. Okay. So at least you basically get to see as to these are the kind of things that can be done, right? Let's say public images. And now I say container anonymous read access for all containers and blob. I say, okay, allow access to the container. And now this is a public container, right? It has access. It allows access basically. Now let me choose another file. I will choose another file now. And this time I will get the URL and I will paste the URL in the chat window as well. So you would also be able to access later when you try out. Let's say I take this one, SQL Server logo, and I uploaded that and I click on that, it is uploaded. So I just take that, I take the URL, and now if I put the URL, I can open the file, right? Hi VS at Lola, welcome. If you click on this URL, you would be able to access that. Okay, so what is the takeaway from here? The takeaway is that you can create such a storage account. You can put any type of data. You can also control the security aspect of it, who should access and how much of it should be accessible to outside world. Okay. Now, a few important aspects of storage account that we need to understand is where I want to come to. In terms of availability, every service that we talk about, you will have to think about availability, right? Because how does that service support better availability? There are different options that storage account supports that availability in. What storage account does is that there are four different ways in which storage account allows you to store data, and those different options are locally redundant storage. Okay, we call it LRS. And then zonal redundant storage, which is called ZRS. And then there is geo redundant storage, which is called GRS. Okay, and then there is also something that is called zone geo redundant storage, which is called actually GZRS. So it is geo first and then zone later. What does it mean? Locally redundant. You created a storage account just like how I did, and I chose Southeast Asia region. Okay, one of the data center in Singapore. What happens is when you choose LRS, this is your data center. Your storage account actually gets stored in one of the data center here locally. Here is your storage account. That's where your data gets stored. Okay. Locally, it will make 3 copies of your data. Whatever data you store, like one image that I stored, it will make 3 copies of that. But entirely, the storage account is only available within that one data center, within that one building in Singapore in one data center. It is not replicating across data center also. That's why we call it locally redundant storage. It is local only. Okay. Now, Bella might say, what happens if that data center goes down, right? My website would be reading these images from here to display. So I can't accept that. Then there is a better option in terms of availability and redundancy of data, right? So I can alter the way it duplicates data. I can go to ZRS, which is the second option, as you saw here, right? Zone redundant storage, which means it can now replicate data across different availability zones, right? Across the availability zone. So we understood availability zone was basically where there were at least two data centers, right? 1 and 3, let's say, two data centers in there. Now, what it will do is that there is one data center here and there is another data center here, let's say DC1 and DC2. And these two data centers are part of availability zone. So what it would do is that it would store 1 copy of storage here, maybe another copy of storage here of the same file here, but it will definitely store third copy out here. Okay, is how it is going to work now. Okay, eventually what would happen is, because we are saying that all the time it would be having 3 copies, right? So locally it would still carry 3 copies, but then what happens is that copy is also replicated in another data center. Now, if one data center goes down, no problem. If let's say this entire data center goes down, no problem. We can still access the data from data center 2. So there is better redundancy now. Okay. The third option is geo redundant. Sometimes now Bella might say, what happens if all the data centers across Singapore go down, right? I still want my data to be available. Okay. So then we say geo redundant storage, geo, across the geography. Okay. Which means that if I have Southeast Asia on one side, and we spoke about paired region in the last session, one of the last session, right? That paired region of Southeast Asia is actually East Asia, which is in Hong Kong, right? We spoke about that. So once you choose GRS option while creating the storage account, or if you configure it in such a way, what it would do, as you can imagine, it would basically keep a copy of your data here in Southeast Asia, but it would also replicate copy of that data in another geography, in another data center in East Asia. It will do that. Okay. Now, let's say three copies here, but it is also replicating this data to another data center in another region itself. So, which is across geography, right? So this is GRS. Now, sometimes what might happen is that, Bella's business grows and there are users, right, let's say across India and Singapore, they are accessing the website. And what we want to do is that for website to be faster, we say that, hey, if the traffic is coming in from Singapore or India, let us go to this storage account, which is in Southeast Asia, and read all the images because it will be faster, right? And then whoever is located in Hong Kong and China region, let's say, right, for that, don't no need to come to this storage, no need to come to Southeast Asia instance of storage account, but you can actually go to East Asia region and read the data from there. So this is another use case where once you are replicating from one region to another region, read operation can be permitted. Read operation can be permitted on the secondary also, which is your East Asia. So that is GRS. Finally, the fourth option is GZRS. Now, G geo and Z zone, combination of both. Much more available, much more redundant, much more durable, right? No chance that you would lose the data. Okay, so which is basically across the region, of course, right? Hong Kong or East Asia, but in every region, it is then also zones, leveraging availability zones. So it is not just replicating from Southeast Asia to East Asia, but within Southeast Asia, across multiple data centers. Also in East Asia, in Hong Kong, also across multiple data centers. So these are the options that you get to choose, okay, from the redundancy perspective. So remember, ZRS and then, sorry, LRS, ZRS, and then GRS, and then finally we have GZRS, okay, Geo Zone Redundant Storage. Now, in terms of the durability, right? See, because as you move from one option to the other, your service is more durable, right? Your data is more durable. There are less and less chances that you would lose data. Okay, so when you are in LRS, you already get very good availability, right? Which actually goes, up to 99.999999999 and 11 nines. Imagine 11 nines total. Two nines here, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 9 here. So total 11 nines is what we call it. It has this much of durability. If you go to ZRS, right, you get up to 12 nines. 12 nines. If you go to GRS, you get up to 16 nines of durability. And GZRS, you get up to, again, 16 nines of durability. So important concept, okay? Remember that. Now, this is in terms of the redundancy and durability. Now, once you create storage account, as you said just now, there are basically four different types of storages that this storage account creates. So now let's talk about storage types. Yeah, so we talk about storage types. So as I was showing you earlier, there are four types of storage that storage account basically provides you. One is blob. So you create a storage account, you by default get these four types of storages created in every single storage account. Okay. You have queue, right? You have table, and then uh, you have files, files type of storage. So these are the four types of storages that you get. And let me just go back to the portal, right? So I can show you once again. Uh, yeah. So here was storage account, and in the storage account we had four types of storages, as you can see here: blob storage, file storage, queue storage, and table storage. So each one of that serves different purpose. So you only need to know from fundamental perspective that there are four types of storages and what each one of that does. Okay, and that is what I'm going to actually tell you now. Okay, so blob you have understood, right? That it's basically kind of a storage where you can bring in everything and dump anything, whatever type of file, right? Whichever format you can bring it and you can dump it is what I told you. So that is basically blob. Queue. Queue is for the cases where you want the data to be processed in a queue. Basically, this is your queue. And what you do is that from one side, you start sending the messages into the queue. You start sending the message, let's say message number 1, 2, 3, 4, 5, 6, 7. Okay. And as the message comes in, message number 1 came in. On the other side, you might have an application, and that application would first pick up message number 1 and it would process that. Thereafter, it would pick up message number 2, then 3, then 4. So it actually becomes kind of a first in, first out type of a solution. First in, first out. As you know, in short, we call it FIFO sometimes. And there are use cases for that, right? Just take an example. Because Bella would be creating a website, there are handmade jewelry images, right? There is a big picture and then there is a thumbnail of that picture. They can use queue storage because there could be another application, say because nobody would be creating thumbnail manually, right? We can leverage the application or a software, okay, or an application. So imagine there are thousands of images. We send all these 1,000 images one by one to the queue, and every image then goes through that application. That application creates a thumbnail of that image and it stores that thumbnail image somewhere. But you want to make sure that all the 1,000 pictures have their thumbnail created, right? So that is exactly what queue is used for. Send one message, make sure the application goes one by one, one by one, one by one. And from 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 my perspective, I can start uploading thousands of pictures, right? One in one shot. Sorry, let's say 100 in one shot, and then I'll come back later, upload another 100, another 100, right? Because it is asynchronous. You can upload anytime. Application would just come back anytime. It will pick up. Just that it will make sure that all the messages are processed. That is the type of storage that queue is. Okay. Table storage. Table storage is simple. Is a simple type of a storage where it only have two columns: ID and key and value. Key and value, right? I might store, let's say some sort of a JSON document in there. I can say 1, 2, 3, and then here I can have some sort of a JSON code that I'm storing. So like a document. And if you haven't seen JSON, it's fine, right? Just understand it like being an HTML type of a document or an XML type of a document. And by document comes in, you put that in here. And every document has a unique ID. So there is ID, document, ID, document, ID, document. Normally no SQL type of a solution. It is not structured. Document could be different, but that is what table storage is used for. And then we have files. Now this files is something that you may be familiar with already. You might have seen in typical setup, if you're working in an office or in a company, right? You might recall that, if let's say this is your machine, this is your colleague's machine, and this is somebody else's machine. We have a central storage. We have a central machine, which actually has some storage attached to it, right? Central type of a storage. And there is some data, and that data has to be accessible to each and everyone. So what we do is that we basically see it as a disk, and then this disk gets mounted on every machine, right? Let's say as E drive. So a network administrator can mount this storage, which is a common storage, onto every machine as E drive, and all of you can then access that common disk. So Azure Files is exactly this type of a solution, but in Azure. So you don't have to create a machine and then use the disk as the storage to do that. It provides you as a PaaS service. So that's what exactly the Azure Files is. Okay. So that is on the type of the storages that we spoke about. Okay. Now, one more thing which I would say is that because you were talking about virtual machines, right? Remember, every virtual machine has disk. If I created a virtual machine, it is going to have C drive, it is going to have D drive or E drive if I want. All this storage is also coming in from storage account. Although it is seen as a disk, but it is coming in from the storage account only. Okay. So there we covered four types of storages. All right. Now, one more thing to understand is that there are different types of data, different purposes. So basically, we have a concept of access tier in storage account. Access tier, and these tiers are defined because not all the data is accessed all the time. Some data could be accessed once a year. Some data could be accessed let's say every quarter. And once the data gets, let's say, older than 1 year, we don't use it at all. Okay. So what Azure does is that Azure in storage account lets you define what is called as access tier. And there are four access tiers that we have. Number one is hot tier. Okay. Number two is cold tier, or we call it actually cool tier, cool tier. Then we have cold tier, and finally we have archive tier. Okay. Why? Different types of data. If you don't use the data so often, choose a tier like cool, cold, or archive. Okay. The reason why we need that is that to make some data available instantly, you need to keep it on a storage which is readily available, right? And if it is readily available, it will be a little expensive because it is ready. You go there, read, you get the data, right? So data that you want accessible anytime, any minute, any second, right? You would like to store it on the hot access tier. Any data, let's say, so we are saying that on a daily basis, if you are accessing that, so use it to store as hot or under hot access tier. Cool is if, let's say, uh, you know you are only using the data up to 30 days. After 30 days, you are not using it at all, right? So put it in cool. 30 days old, automatically send it to cool, right? Because the moment you send data from hot to cool, you actually pay less money to Azure for storage, right? So look at it that way. The faster you can access, the expensive it is. Okay. So therefore, if the data is not being accessed, send it to either cool and then maybe from cool to cold and then from cold to archive. So this is basically on a daily basis. If you are accessing data on a daily basis, if let's say 30 days old data don't get used, put it in cool. 180 days, older than 180 days, put it in cold tier. And let's say if it is greater than 180 days, then fine, you put it in archive. So that's how you manage the cost. So you identify different types of data and then you create basically this life cycle, and you can do that automatically. Okay, you can do that automatically. Let me just go back to the portal and I will very quickly show you that. So I come back to the portal, and if I go to data management, lifecycle management, it will let you configure. Okay, data gets older than 30 days, please move from hot to cool, right? And then from there to cold. So you can actually define these rules here. You can define these rules. Any name, apply rule to all blobs in the storage, blob type, and whatever. And then you see if the file is last created or last modified more than 30 days, let's say, then either delete the blob or move to cool, move to cold, whatever, right? Let's say move to cold, add, and done. That's all. Okay. So it is actually to allow better control over the cost depending on the type of data. If you never use, put it in archive, most cheapest option. But if you put it in archive, if you want to read it, then you have to give Microsoft some time, a few hours, because before they can rehydrate that data from the archive. Okay, so you can do that. Now, hot. Since we were talking about hot, right? One more thing is, if you come to storage browser again and you go to blob container, and I go to, let's say, public images, right? And you see access tier is hot. By default, it is hot. If I'm uploading some data to be in, for example, to be in cold tier, what I can do is that when I upload the data, at that time itself, I can say whether I want this data to be cold, cool, or whatever, whatever that I want. I can do that. Yeah, so if I browse this file here another time, and I choose any file from here, any file, right? Let's say this file. And if I go to advanced, so you see here, you see access tier. So I can say, okay, upload this file as cool. I know already, so don't have to go to the hot. So you can do that also. Okay, so I hope this is clear. Right. So see, yeah, and that is all that we have to talk about when it comes to storage account. Okay, and rest, of course, after these sessions are concluded, once you have gone through that, then I would advise you to take a read of the material on Microsoft Learn about AZ-900, and what we are discussing here would help you to then very quickly iron out all the content. There would be a few topics and concepts that we have not covered as part of the training due to some time constraints, but overall, you should be good and you should be able to understand what they're talking about. Okay, right. Now, one last thing which I would talk about is, let me come back to the whiteboard, is that on one side you have basically your data center, right? Your on-prem, and then here you of course have Azure, and in Azure you have storage account. Storage account, there would often be a need where you want data to be coming in from your on-prem to storage account in Azure. There are different tools that we can use for that purpose, but just remember one tool that is called AZ copy. Don't go into technicalities. Remember, AZ copy is a command that you can execute over the command line. You tell the source wherever the files are located, and you tell the destination in storage account. It would basically help you to move data from here to the cloud. Okay, AZ copy. So remember that. So it is basically a tool to transfer data and to also migrate data from your source to the destination in the cloud. Okay. Sometimes you might say, hey, I'm not migrating. What should happen is that any data, I have a storage here and I have a storage here. Any data comes here, that data should get replicated to storage account. Anything that gets created in storage account should get replicated to my on-prem also. So basically two-way sync all the time. For that, we also have something which is called Azure Sync. It's an option. It's an option, a service that you can use. Just know conceptually that it is possible. There is a business case for that, and there is a service for that. Just know that much. Okay. Right. With that, I'm done with the storage account. Any questions, put it in the chat window. Now, yeah, put it in the chat window if you have any questions. And what I will do is that with that, I will just move on. I'll just move on to the next thing that we have to talk about. Okay. Right. Now, next thing that we want to talk about is security. Very important. Very important in cloud. Why it is so important? Because cloud is open. You can access it over the internet, right? Data services. Just now I shared a URL, and you can click on that URL. You have access to the data. I allowed you, so you can access, right? Generally, I would not allow, right? So cloud, everything is available over the internet, correct? But then what happens is, since it is available over the internet, and provided you allowed somebody, even accidentally, they will have access. So for that reason, we need all the more guardrail when it comes to security. So cloud, for that reason, in general, is much more stringent, much more secure than in on-premises, because we know that it is accessible over internet and there is a little bit of glitch, data can get leaked out. Therefore, security becomes very, very important in cloud. In the data center, you might say, hey, this is building. As long as my building is protected, there is a perimeter, nobody can come in, come out, I'm safe. No, that is not the case in cloud anymore, because it is open, right? It is available over the internet. So Security should be taken much more seriously when it comes to the cloud. Okay. Now, when it comes to the cloud, you look at it this way that we have to approach security in this manner where we need to basically assume threat, right? We need to assume threat. We don't say that, hey, if I'm in my data center, if the machine is inside my data center, it is safe. No, we cannot actually assume that in cloud. So in cloud, we follow what is called as zero trust model. We don't trust anybody. And even if it is our own employee, we don't trust them either. So every time you want to access something, you tell us that you are the right person. Okay. You are the right person. So the right person means that firstly, you authenticate yourself, right? You firstly authenticate yourself that you are basically the right person who should have access. And for that, you need to have a valid identity. Okay. A valid identity that is recognized. And once your identity is validated, say for example, if you're working somewhere, you go there and you basically type in your user ID password. That is your identity. You go to Gmail, you use your email ID password. That is your identity. So you provide the correct password and email ID. Only then you are able to log in. And these are days, sometimes Google will ask you to then basically, approve a notification on your mobile phone before you can log in. Correct. So all those things are coming in because these are cloud services. They need all the more security. Sometimes just entering user ID password is not enough. You need more, right? Let's say notification over the email. Only when you approve, you are allowed to access. And all that is called basically that is authentication, right? So you have an identity, okay, and then there is authorization. So authenticate and then authorize. So authentication is your identity, whether you are a valid user, valid person. Okay. Authorize means whether you have access to do something. Okay. Whether you have access to do something. You could be a valid person, but if you don't have access to access, let's say the jewelry images from the storage account, you will not be allowed to access. Okay. So these two things we need to look at: authenticate everybody, be it internal or external. It doesn't matter. That's why we say zero trust. Trust nobody. Let them authenticate themselves. Okay, and only if they are authorized, they get access. So authentication and authorization are two aspects. So authorization is all about whether you have access or permission to do something. Okay, whether you have permission to do something or you have access to do or you have access to do something. So that is what this authentication and authorization means. How have you been doing this in on-prem or traditionally? And you must have heard about it, right? Windows Active Directory, right? Windows Active Directory, AAD. We do it in on-prem this way. That anybody joins a company, my company, Bella's company, right? There would be an Active Directory which is installed on a machine or on a server in on-prem, but it registers every user, every identity. Let's say I join in Bella's company, Deepanshu. An identity will be created in Active Directory, and that identity is then used all across the business. Okay, but this was an on-prem. When we talk about Azure, when we talk about in Azure we have what is called as Microsoft Entra. Microsoft Entra. So Microsoft Entra is nothing. In on-prem you had Windows Active Directory, and in Azure you have Microsoft Entra. So as is the case with many services, that we are offered the same functionality as a PaaS service or as a SaaS service. This Microsoft Entra is basically a SaaS service, software as a service. Okay, allows you to do exactly the same thing: manage identity, and manage access. And we basically commonly, also call this aspect as IAM solution, which is identity and access management. Now, if I am on Azure, I create a virtual machine. Who can access? I need to create an identity. That identity will be created in, should be available in Microsoft Entra. Okay. Some, Bella might say that I am already running my Active Directory in my data center in on-prem, and I want to continue doing that. Okay. But some application I will put on cloud. So she's not moving out entirely. Let us assume that. In that case, she can continue to run this Active Directory on-prem in data center. But then from there, we need to sync all these employees from Bella's business over to Microsoft Entra, because the same employees need to get identity and they need to get authenticated also, right? And authorized also. So in any case, identities have to be there, and IAM solution has to be there. It could be on premises or it could be in Azure. If it is in Azure, it would be Microsoft Entra. Know that. Okay. So this is an IAM solution. Now, there are different, there are different aspects of IAM solution. For example, I was talking about Google example, right? And I'm sure all of you must have heard about this thing about multi-factor authentication these days. Multi-factor authentication. That the username or your user ID, the password. Knowing these two is not sufficient. There has to be one more mode of authentication. So there should be multiple ways to authenticate, not just password, because password may get leaked out. Anybody would be able to log in and do whatever. No, they should not be. And that's why when you go to Google, you log in from somewhere, you get an alert on your mobile phone. Please approve. Are you trying to log in? That is multi-factor authentication. Sometimes somebody would call you over your phone. Sometimes there would be a notification. That is multi-factor authentication. It is required to make it much more safe and secure in cloud. Okay. So zero trust we assume, and to then make it more and more secure, we then have things like Microsoft Entra, multi-factor authentication, and even conditional access, right? Things like this storage account can only be accessed from India. Now, if Bella is running only the business in India, only in India, then why should she expect unnecessary traffic, let's say from outside of India? She can say anybody who tries to access my website from outside of India, don't allow even. She can say that. Okay. We can say, somebody should not be able to connect to the virtual machine if they are sitting somewhere where Bella does not expect them to be. Let's say Bella is running the business in India and somebody is trying to log in, let's say from Malaysia, suspicious, right? So you can say, don't allow. That is conditional access, right? That only allow login from this country. Only allow login from one particular building that has defined set of IP addresses. You can do all of that also. Okay, so remember that. So all these are security mechanisms. All right. So understand that, and yeah, there is one more thing that I would like to touch upon. And you see, please keep in mind that we are not basically covering each and every aspect of everything. Okay. So later, when you are going back and reading the content thoroughly, there would be some things that we have not covered, but it should help you understand whatever is there much more easily. I want to talk about this concept when it comes to security about defense in depth. Defense in depth. Cloud follows defense in depth. Defense in depth means how many layers do you see? If you ask me, I see one layer, two layer, three layer, right? Four layer, five, six, and basically seven layer of security, right? Is what I see here. Now, let us talk about Bella's business, okay? Bella's business. And I start with the physical security. So Azure basically works on this principle of defense in depth, that there are different layers that actually apply security. So not that there is only one layer, and if that layer is compromised, you are gone. No. Every layer would challenge you, would challenge somebody. For example, physical security. Microsoft data center is available somewhere in India, let's say, right? Let's say Central India region of Azure. And in this region has multiple data centers, and these data centers are physically protected. Not that anybody walking on the street can go there and enter inside the data center and do whatever. No, that is physical security is there. You restrict people from going in, right? And then that is settled. Now over the internet, what do we do over the internet? That that's where we talk about identity and access. And for identity access, I already told you IAM solution. Implement identity and access management solution or IAM solution. So use Microsoft Entra if you are 100% on cloud. Use that. That's where you create user ID, password, right? Security groups, etc. All that. If you are in on-prem, continue using that identity provider like Active Directory or whatever, or any third-party identity management system, fine. But then replicate, sync all these identities from on-prem to Azure. Because you're running even a single application in Azure, you need to do authentication authorization. For that, you need identity. So that syncing is at the least required. Okay. All right. Now comes perimeter. Perimeter is, Bella has a website. And what happens is on the website, as her business grows, there could be malicious element because see, website is available, right? A URL, and every time somebody goes to the website URL, press enter, there is a request goes back to the server, and server has to do something to load that page for you, correct? Some processing needs to be done. We have this concept of what is called as distributed denial attack, DDoS, DDoS, which is called as distributed denial of service. Some malicious actor, they might send so many requests, automated or RPA based requests to the website that it can overwhelm the server, right? Let's say thousands and thousands of requests every second they are pushing from their side. And that can literally bring the website down because the backend is not prepared to take so many requests. And it is not realistic to receive so many requests, but these are the distributed denial of service attack, right? That malicious actors can pose. To protect against that, we have perimeter. And to prevent such type of attack, Azure in every service they have built-in DDoS protection, distributed denial of service protection, wherein anybody who is coming in like that or creating so many requests would not be allowed to send so many requests. It will block it right before that. So that is perimeter. Okay. And then network. Network, you see, we talked about having firewall. We talked about virtual networks. We talked about network security groups, right? Restricting the traffic. How can you restrict the traffic? All that is at network level. So even if perimeter is compromised, I still have firewall at the network level, right? So it's how you see. So one level gets compromised, another layer still puts a defense. Is what is happening here. And then compute, right? Compute is your virtual machine. Then not everybody can access my virtual machine. There need to be a user ID password, of course. So if somebody don't have, they can't do anything. Okay, even if they could access the VM, let's say RDB to the machine, but if they don't know user ID password, what is the use? They can't do anything. Even though network layer was compromised, but they still couldn't access the compute. Okay. And then basically at the application level also, at her website level also, we can have authentication that, okay, let user log into the website before they can place an order, before they can do something, right? So we can do that also. We can say at application level, we would allow first users to log in using either their Gmail account or their Facebook account or whatever. That authentication is there, application level authentication. And then finally data. Data is where she's storing all the inventory, transactions, payment details, etc., etc. At that level also, we have many, many things. Data, we have many, many things, right? You can encrypt data. You basically encrypt data. Even if somebody gets access, they can't see what is there. But before that, you authorize, you basically deny, right? You manage authorization. You don't allow anybody to get to the data layer at all. Only database administrator can access, right? But even if they can access, you have provisions that data is encrypted. Even DBA cannot see how much an employee is making in a company because data is encrypted, right? So what you're trying to say, defense in depth is what Azure follows. Every layer has basically is putting up a defense. Okay, every layer is putting up a defense, and therefore we consider it to be much more safer than the normal on-premises solution. All right. So that is all I had to cover in this chapter. And now, with that, let me move on to the next chapter. So we are done with the storage and the security part, just to let you know. Okay. And now I'm moving towards the last part that we are covering here. And that part, so see, these are the slides that I'm keeping for my reference. But anyways, the idea is not to go through the slides. Okay, so the next thing, and this is basically the last part of this training. So let us get to that. Yeah, so this is what we have done so far. And again, this whiteboard will be made available. So feel free to come back anytime. Yeah, so this is what we are going to cover in this last part. So don't worry, it doesn't require as much time as the previous section took, but I would spend a little bit of time now on firstly the cost management. Cost management would be an important aspect, right? You shouldn't spend more than what you are required to spend. Governance and compliance, we will talk about that. Resource deployment, how do you deploy resources? See, I deployed storage account. How did I do? Using the portal. At scale, I will not do that. I will basically programmatically write everything, and then that's how I will create these resources automatically. Okay, so what are those deployment tools? And then finally, monitoring tools. Now, see, all these aspects that we are talking about, they are more relevant from the administration perspective. So you understand not just being a consumer, but you understand what does being in cloud mean when you are responsible to manage infrastructure in Azure. You need to keep cost elements in mind. You need to configure services in such a way that incur less and less cost. How do you manage the cost? How do you monitor the cost? Right, is what we need to understand. And then, yeah, we will go into the governance as well. So let's get started with the cost management first. See, what happens is, and there are 2 to 3 things, right, that I will talk about when it comes to cost management. Firstly, you need to know how much you're spending in Azure, and you're creating resources and you're not keeping a track of how much you're spending, then it is basically not good, right? So what Azure lets you do is that if you go to the portal and if you type in cost management, just type in cost management and billing, okay? Click there, and what Azure gives you is basically a track of everything that you are doing in here. You see, if I go to cost management, that's where as a administrator you can come and you can see everything wherever you are spending some money. Okay, wherever you're spending some money in here. Yeah, so cost management and cost analysis. And remember, it is selecting Visual Studio Premium with MSDN, and it is nothing but my subscription. Now, if you recall, we know already that the billing is done at the subscription level, right? Billing is done at the subscription level. So that's what it is doing, that it is telling you that, okay, whatever data that you see when it comes to the cost management, that data is basically coming in from one subscription, right? Which is this subscription. So I come here to the subscription and no billing. This is strange. One second. Yeah, this is better. Okay. So cost management, you see. Now what you see here, a view, how much have I spent so far and what is my forecast. I told you that billing is done on a monthly basis, right? So on a monthly basis, it is basically looking out, for that month, and then based on that, it is telling you how much have you spent so far, okay? And then what is your forecast, okay? And this is from April 22, May May 19, and these are basically the dates. So you can actually choose different filters here. Let's say only talk about this month, right, which is July. So let's choose for the month of July only. So it is showing me, okay, I spent $19. Forecast is 2031 at this rate. I can do that. Not just that, it also tells you I spent $16 on storage, virtual network $3, virtual machine 20 cents, and all bunch of services. Also the region, and also where the resource sit, right? Which resource group has incurred how much of spending for me. So you can keep a track of all those cost related elements. Okay. Now every company will have some budget, right? So you can also set basically budget that, hey, like my budget, I'm using a free subscription. My budget monthly is 150. I can create a alert, right? I can create a budget. I can set my budget to be 150, and I can create a cost alert also to say that, okay, 80% consumed, please alert me that 80% cost is gone. Because if I don't keep a track of that, I might overspend, right? And if you have a credit card or a bank account associated, right, it would incur cost and you wouldn't know. So cost management, you have to keep an eye on that, and you can monitor that on a monthly basis. Okay. So that is monitoring. How much are you spending in Azure and where you are spending is what you do with the cost management and billing. Okay. The other thing is, there is this thing which is called as pricing calculator. Bella is looking to implement a website in Azure, and we know typically as to there would be some infrastructure that she will need to set up, right? So for example, she will need to have, let's say two web servers. Okay. Yeah. So two web servers. Then there would be two app servers, and then there would be one database server, let's say. So overall, I need five VMs. Okay, I have a count of that. I will need one storage account, let's say, to store the images. So these are the two things that I require. Now, Bella doesn't know how much money would she need to spend. So Azure basically offers you to give a sense. Azure gives you this pricing calculator. So you can come here, and what you can do is you can basically select the type of resources that you're going to provision, and it will give you a rough idea as to how much would it cost to run that on a monthly basis. So for example, I can choose virtual machine. Okay, add to the estimate. What else? I would need a storage account, right? So I can add the storage account, and that's all. There are a bunch of services you can see. You can select everything from here, but I choose only these two. And then for virtual machines and as well as for storage account, you select okay, which region. Let's say East US, Windows OS. Okay, whatever. How many machines do you need? I need five machines of this configuration, and I would be running 24 into 7, and this is the size of the VM. How big, how small the machine is. I keep it to, let's say, 2 core. Okay, fine. Now with that, it gives me as to how much would it be costing me on a monthly basis, right? Average per month, I would be paying 657. Okay. So this is what I would be paying to Azure on a monthly basis if I were to run these five machines. Pay as you go, right? But there are different saving plan, right? You can say, okay, commit for 1 year. I mean, I am basically saying that rather than paying on a monthly basis, right? I can commit that I would be running it for the 1 year complete non-stop, or for 3 years complete non-stop. And if you choose that option, then your cost would basically tend to come down. It would basically lower down. Okay. Uh, right. So actually, the type of compute that I've chosen, it actually doesn't support those 1 year and 3 years options. So maybe let me just choose that. And now you can see, right? If it is generally costing about $1,000, if I commit that I would non-stop run for 3 years, the cost comes down to 550 only. So it is like a commitment from your side to Azure. I'm going to run it for 3 years non-stop. Tell me how much discount can you give me? And that is reserved instance, that Azure is reserving this for you for a period of 3 years. and thereby you save cost. Now, Bella has a plan to run the website non-stop, right? So it is a good deal for her to basically take the reserved instance and go for either 1 year or 3 year fixed. Okay, right. So that is cost management and pricing calculator, where you can actually then get a sense. Similarly, I can go for storage account. I can choose whatever I want, and then it will give you the cost. And then finally, I can export it in an Excel. So it will give me a view as to this is how much Bella would be spending on a monthly basis, provided these are the configurations. Okay, you can use this pricing calculator for that. All right. Okay. So that is one thing. Now, other than that, the other thing which I want to talk about is about governance. Governance a little bit. Right. Governance. Let's talk about governance. I'll say governance is very, very important. Why is it important is because you know every organization want to function in a particular way, right? Let us say if you are a bank, right? Bank might say, or if you are a government agency, right? Let's say government might mandate you that whatever data that you are storing, let's say in case of India, any data with regard to the Indian citizen must reside in India. Now that is a mandate for any government agency, right? Now if that is a mandate, it has to be enforced in cloud. Let's say, the Home Ministry of India decides to adopt Azure, right? They want to enforce in their Azure setup that any resource that is created, be it virtual machine or storage account, it has to provision in one of the region which is inside India physically, right? Not outside. Now, saying that is one thing. These policies are enforced by the government or by a company like a bank or by an insurance company, let's say. Different types of businesses might have different types of compliance or regulatory requirement. And this was just one example, by the way. But on the other side, what happens is how do you implement it in Azure? How do you configure it to say that that any virtual machine should only be allowed to be provisioned in any of the region, but only within India, right? Let's say there are three regions in India. It should be either this or that or that. If you choose any other region outside of that, it would not let you create resource at all. Is one example of governance. Okay, and you need that, and not just regulatory requirement. You might say, let's say you have a budget of 5,000 USD per month, and somebody goes in there. You hired a new Azure administrator. This guy goes in, and he actually provisions a very big machine which has, let's say, hundreds of CPUs and so much of RAM, right? Terabytes of RAM. And let's say he does that accidentally. Machine is created running, nobody observed, and your 5,000 is gone. Shouldn't happen, right? So by policy, you can also say that, okay, don't let anybody provision any virtual machine which is which has more than four CPUs, for example. You do that with the help of policy in Azure. And that is the kind of governance that we're talking about. So you discipline, you enforce what should be done, what should not be done, be it regulatory reason or be it administrative reasons, okay, is what policy or the governance is all about. So in Azure, we have a service which is called Azure Policy. Azure Policy. And pardon me for my handwriting, but I just want to come back to the portal and I'm going to show you right here in the portal. So I go to policy, and if I launch policy, that's where I define all the policies for different types of services for and different policies for every type of services. And when I define that, right, what happens is, you see, this is the portal. This portal is keeping a track in this subscription of all the resources, right? And any policy that I create would be available here. Now, policy is nothing but it has some rules. One rule could be only allow virtual machines to be provisioned in one region. Only allow virtual machines of a certain type to be provisioned. Storage accounts should only be provisioned in Southeast Asia, right? Such type of rules. Any storage account should have public access disabled. Like just now, in my storage account, it was disabled, but then I enabled it so to let you access. But you can say that please keep it disabled. Now, that is a kind of rule that you have enforced, by the way, with the help of policy. Okay. And once you have the rule defined, it could be one rule, there could be multiple rules, right? So what you can do is that you can actually, if it is one rule, fine, one individual rule. There are five rules, five individual rules. But you can combine these five rules into something which is called as initiative. So I can have, different rules. I have different rules, let's say one, two, three, four rules. And I can combine them into something which is called as initiative. So initiative is nothing, but it's basically a bunch of rules, policy rules that you have defined. Now I can combine all the four into one, and then I can say, okay, this initiative apply across entire subscription, apply this across entire resource group, apply it across entire management group. Now remember, we spoke about management groups, right? We spoke about subscription. Now you are creating policies, but then you are not going to, let's say there are 10 virtual machines, 100 resources. You don't have to go to every resource one by one. Go back to the parent. Not resource, go to resource group. Maybe not resource group, go to subscription. If not subscription, go to management group. And you can enforce right up there. Okay. So that is what Azure policy allows you to do theoretically. But what it is doing here, and you don't have to go into the practical, right? You just need to know the concept. But what you see here in the dashboard is that it is telling you zero compliant for non-compliant. So there are some policies by default available, as I can see. And, I see that the resources that I've created, they are not created in a way in which the policy expects them to be in. That's why it says that there are four non-compliant resources. I would like to see it 100% compliant, by the way. Any organization would like to see 100% compliant. And if it is non-compliant, why is it not compliant? Right? So all that is what you do here. So basically compliance would give you the compliance dashboard. And once there is a compliance issue, something is non-compliant, how do you remediate that? Right? All that you can do here. Okay, so maybe I think just conceptually understand that policy is to enforce compliance, regulatory compliance, and some rules. Okay, and then there are initiatives which are group of rules that you can enforce over either the source group or over subscription or over to management group. You can do that. So what I wanted to show you is that I can basically create a policy and I can assign policy also. So you can assign policy, create policy, you can create initiative, and you can assign initiative also. Okay, right. So keep that in mind that policy is there and policy helps you enforce that. Okay. Now, there is another thing which I want to tell you guys about is this thing called as Azure Resource Manager. So let me just get the screenshot in here, and then I'll talk about it. Yeah, let me get that screenshot here. Because this ARM is something that you would hear very very often. So good that we touch upon what this ARM is. ARM, by the way. Azure Resource Manager is what it stands for. ARM. ARM. So see, as you read, ARM provides a management layer that enables you to create, update, and delete resources in your Azure subscription. Okay. Look at it this way. You understand it this way. Just now I created a storage account. How did I do that? I went to the portal. I launched the portal. There was an interface. and I said, please help me create a storage account. And I entered some configurations. What happened behind the scene is that those instructions were then sent out to Azure Resource Manager. Okay. And then Azure Resource Manager actually used those instructions. It actually compiled those instructions into something called as ARM template. ARM template. Okay. And that template was then sent out to Azure infrastructure to provision a virtual machine, or to provision storage account, or to provision any type of resource that I want to provision. Okay. So understand what the ARM is. It is actually the framework, or it is a layer, management layer, that is responsible to provision any resources in Azure. Any resources in Azure. The way you create a resource could be different. It could be through portal. Not every time I will be creating through portal. Let's say there are 100 virtual machines which are to be created. I cannot do it manually. I will automate that, right? I will perhaps use Azure PowerShell to automate that, or I can use Azure CLI to automate that, or I can use REST client, right? Let's say use Java client or C Sharp client, and somebody can write code in Java and C Sharp to provision these resources. But irrespective of whatever way that you use to provision resources, at the end of the day, it all gets converted into, it all gets sent out to Azure Resource Manager, and Azure Resource Manager streamlines all that into what is called as ARM template. And then those ARM templates are used to execute and provision the actual resource. Okay, right? So from portal to Azure Resource Manager, Azure Resource Manager creates an ARM template, and then ARM template is what is used to provision that. Okay, is what we are saying. Now, if that is possible, if it is the ARM template that is required to provision a resource, why can't I simply have an ARM template and execute it straight away? And that's how the automation gets done. We basically pre-prepare these ARM templates for everything, and we just execute the ARM template. That ARM template might have 5 virtual machines added in there, one storage account being added in there. I would just run that ARM template, and it will create 5 machines, one storage account for me. It could be 50 machines and 10 storage account also. It could be 500 machines and hundreds of storage account also. Okay. So that ARM template is what Azure Resource Manager uses. Okay. Azure Resource Manager is responsible to let you create, update, and delete resources in your Azure subscription, is how you understand that. Okay. I can show you ARM template. Let me just very quickly show you ARM template. How does it look like? It's basically a JSON type of a template. And if I go back to my portal, right, uh, you know that I think the other day we created a virtual machine. Yeah, I'm going to any resource actually. I can go to any resource because every resource would have its respective ARM template. So my desire is to only show you that. Maybe I just go to storage account, the one that I just created. Let me go to that account and I will show you the ARM template for that resource. Bell static, right? So let me click on that. And once I have that, and you come back here to the automation, you come down to the automation, you will see export template. Okay, you click on that. This is your ARM template. You see, this is your ARM template. It is generating that, fine, but I can actually take this template and I can store it as a JSON file. And by using a bit of a PowerShell or Azure CLI, right, I can execute a command, and all this JSON consists of all the properties and configurations that I used to create this storage account. So from administration perspective, it is much more easier for us to maintain these ARM templates. These ARM templates. This ARM template is only for one resource. But imagine if I go to resource group, and that resource group has hundreds of resources. I can get an ARM template for the entire resource group also. And that template I take and I keep it. And anytime I execute that, all the 100 resources get created. When I don't need that, I delete the resource group. Everything gets deleted. And that's how you automate. That's how you do DevOps, right? Because DevOps is all about automation, right? So ARM template is what we use for automation. We provide this as a code to our DevOps pipeline. Pipeline would execute and it would take that ARM template, execute it. Resources are created. Entire production environment is created. For development environment is created. Test environment is created. When not required, delete all of that. Okay. So when we talk about DevOps, that kind of automation, the kind of automation is actually supported by ARM template also. Now, ARM template is one way, which is Azure native way. You can also use a Terraform. You must have heard about Terraform, right? HashiCorp Terraform. There is another way which lets you create infrastructure by using code. And that's why we say infrastructure as code. So ARM is one way that you're creating infrastructure as code. HashiCorp Terraform is another way in which you can write their respective language. And then your DevOps pipeline will take either an ARM template, right, or a Terraform template, right, and then that will get executed. Your environment is created automatically. When you don't need that, everything is deleted. So there is nobody sitting there and doing it manually. Remember that. Okay, so all that is done by Azure Resource Manager was the message that I wanted to leave you with, and it is an important thing. So you should know that. Okay, infrastructure as code. Yeah, I mean we basically talked about that. Okay, and now last two things that I would cover before I before we go towards the end of the session is Azure Monitor and Azure Advisor. So I think it will be good that we go back to the portal and we talk about that here in the portal itself. Firstly, you create hundreds of resources and there has to be monitoring of these resources, isn't it? An Azure administrator would have to monitor, a system administrator would have to monitor as to what is happening, right? How is how are my services working, for example, right? Are there any issues with my, with the services that I'm using? Azure Monitor is a service that monitors every resource, every single resource in Azure automatically. Okay. Now, you see here, if I go to, let's say, virtual machines, okay, I click on view virtual machines. I might not have any virtual machine, there would be nothing coming up. But if I go to storage account, I mean, there is storage account I know I created just now, right? So definitely it has to come up. But Azure Monitor is monitoring every single resource by default for you. And it is monitoring every single aspect of that. See, for example, for this storage account that I created, how many transactions have there been? 171. You see, it is not safe. It is not safe to open up something for the public. And is how you realize. I opened it for public and you can see people are trying to do. People are trying to play around with that. Okay. Transaction timeline, you can see end-to-end latency, server latency, client other error in case there are any, right? So all that you get to see here. In terms of capacity also, it would give you some insight if it is applicable to the resource, which is not in this case. So monitor gives you capability to monitor everything. If it is a virtual machine, how is the utilization looking? How utilized my machine is? CPU utilization, 50%, 70%, 80%, right? You can also say that, hey, I'm running my database. Bella is running database server on a VM and it has to perform faster. So anytime Azure Monitor finds, because it is monitoring it on a real time basis, anytime that utilization of the database server goes above 80%, right? I can say that please alert somebody, send an email so that we can take timely action. Because Azure monitor is monitoring all these metrics about every single resource, we are able to do that. Okay. So for the scope of Azure Fundamental, know that every service is being monitored. Every service has its own metrics. For virtual machines, it could be CPU utilization. For storage account, it could be number of reads, number of writes, right? All these are being monitored. And you can come back here and you can actually check the logs of everything that is happening here because it would keep it for like 30 days, 40 days, 60 days. Okay. It would keep all of that here. That is Azure Monitor. And then we also have something which is called as Advisor. Advisor is also important service in Azure. It is an important service in Azure because it basically gives you advice, like free advice, right? Free advice, but that you should listen to. Normally, there are too many free advices, you might not appreciate that, right? But Azure Advisor gives you advices or recommendations that you need to act upon. Okay. Recommendations could be cost specific. Okay, I provisioned a virtual machine very big in size and I'm paying hundreds of dollars per hour, but I'm only using it 30%, right? The utilization is only 30%. Should not do that. We should not do that, right? So it would tell you that reduce the size of the VM, you will be able to save some money, right? Security related, in case there is any security glitch that you have. Performance related, okay, if something is not performing well, if there is a need to, let's say, increase the capacity of something, it would basically tell you that. Okay, and then there are basically reliability specific advices also. And if I just click on reliability advices, let's take a look. See, it is saying that migrate classic storage account by this date, create an Azure service health alert, use net gateway for outbound connectivity, etc., etc. Some recommendations it is giving, which will make sense to somebody who knows Azure, right? So they can come here and they should review all the advices. At any point in time, there shouldn't be something which is a red or orange or yellow. Things should be green all the time, right? So advisor would keep an eye on whatever you are running, how you are running. In case there is a scope for improvement, it would advise you, and then you take an action on that. Is what it does. Is what advisor does. Okay, so yeah, see, I will. Yeah, that's where I will stop. And now there are other aspects as well that, of course, we have not covered as part of the training, but I would purposefully want to, you know, call it up here uh, with basically complete openness that you still have to go back. You still have to go back and you have to read the material about AZ-900. So where would you do that? After watching the trainings, go to Microsoft Learn Azure Fundamental Certification. Okay, and I'll just show you that. Go there, and as you scroll down, beginner level, you can see all of that. Read this, continue this course, and go through it. I don't think it would take more than 2 to 3 hours for you to complete this. And you do that 2 times, you will be good. You would know. Okay, and maybe note down as you are reading. Just note down on paper, on A4 size paper or whatever, so that you can reference it anytime in future. If you are, let's say, facing an interview or whatever, then you don't have to scroll through the website, take the notes, review, and you are done. And when you are handwriting, it would basically retain better. Read through all this. It is pretty much what we have covered, with some additional concept that we did not cover, but that's fine. I would say 70 to 80% we have covered. Read through that. After that, if you're looking for doing the certification, okay, I would say that you look for this, which is called Microsoft Azure, mm, Microsoft Azure Training Day. Microsoft Azure Training Day. Yeah, MATD. And if you come to this URL, look for fundamental. And this is where you can actually register for one of the upcoming Azure fundamental session. As you have spent some time here, I'm asking you to spend some time there. You register for an upcoming session, and we have discussed that in the group, right? So, but you can actually find out an upcoming session that we have. Let's say this Azure Virtual Training Day Fundamental, whenever it is. So the next is on 8th of August, right? You click on register. Maybe look at the time zone also. If you can find something in the IST or in your time zone, that is better. But this event is full, so look for another, right? There would be more and more coming up. So the reason I'm telling you this is, go there, register using your email ID, attend that 2 and 2.5 hour session over 2 days, because this will give you a voucher. Once you complete that training, after a few days completing, they will email you. They will email you the voucher on your email. You can use that voucher to get 50% off on your Azure certification exam. So if it is costing, let's say 4,000 in India, it might just cost you 2,000 rupees. Okay, so you can. So I think do that if you're really keen. But other than that, on this page itself, there are plenty full of resources for you to prepare. You read through, you can give this practice exam here. Take the practice exam once you have prepared enough, right? So you have listened to the training that we have done, 4 sessions. Once you have done that, then I would say 70 to 80% you are done. Come back to Microsoft Learn, scan through the content, right? Just iron it out, and I would say you are 90% prepared. 10% for the voucher. Go there, register, just mark your attendance. If you are keen, just listen in, right? I think one more time, if you listen in, you would be very well prepared for the exam. Get the voucher, schedule the exam. Before the exam, once you feel prepared, give the practice test, take the experience demo, exam experience demo, take that. So you are familiar as to how does exam look, a real exam look. And then you can give the exam from your home also. You can give it online. Okay. So yeah, that's how you should actually bring it to a logical conclusion.